Hi everyone, welcome to another MSI Insider live stream. Today I'm here with Ruud again.
Hi.
Like last week, you're becoming a regular, Ruud.
Yeah, I shouldn't make that a habit, but well, these topics are they suit me well.
This is your cup of tea, right?
Yeah, that's it.
Yeah, because today we're going to talk about motherboards and the new Intel B460 and H410 motherboards to be exact. So these are also LGA 1200 motherboards ready for Commodore Lake S CPUs, like the ones on Z490 we talked about a couple of weeks ago. But before we get into it, we have a giveaway today. Go to msi.com/2/insider. There you can join our Gleam giveaway. You can perform certain actions there. The more you perform, the bigger chance you will have to win. Our bot in the chat will also spam the link once every 6 minutes, I believe. I see angry people because Ja is not here. Ja was here last week, and I think next week again, not sure. But we'll see. Ja will be back, don't worry. Yes, if you have any questions in the meanwhile, please drop them in chat. First in the stream, we will talk to Simon from Intel. He will tell us everything about the new generation CPUs, about the new chipset. Then we will introduce you to the new MSI models for B460 and H410. And in the end, we will also do a demonstration. We have 2 demo setups right in front here. And we will demonstrate how you can get maximum performance out of your 10th gen Intel Core CPU on one of these B460 motherboards. So let's first get Simon in here. Hello, Simon.
Hello.
Can you hear us?
I can hear you. Can you hear me?
Perfect. Yeah, we can.
Excellent.
Welcome.
Me all right?
Yeah, we can also see you. Good to have you in the stream. So, to everyone watching, Simon works at Intel. Maybe, Simon, you can give a short introduction about what you do at Intel.
Yeah, sure. So, I'm the one of the technical sales people. So my job is to try and explain the benefits of Intel technologies, more specifically in the consumer area, to understand why you should actually buy these products, right, and what the new features are. So that's my day job.
Perfect. So to the chat, if you have any questions, please drop them here. I will pass as many as I can on to Simon to answer. I see a first question, what's in the box though? I'm not sure what box you mean, so I'm not sure if this question is targeted at Simon or to one of us. Oh, they like your hair, I already see. That's always good to hear.
Lockdown hair, everyone's got to have it, right?
Yeah, I need to get a haircut, but the barber was fully booked. So I think in a couple of weeks there's place again. So until then they have to deal with me like I look right now. So yeah, you prepared a couple of slides. Let's take them here and please introduce the 10th gen Intel Core CPUs.
Yeah, sure. Okay, so first things first. It's, we make this claim, it's the world's fastest gaming processor, because when we design the products and we bring out new products every year, we look at what people are doing with the PC, right? So main usage of these things is gaming, but I understand not everyone games all the time, but we've got a whole range of products for all sorts of usages, okay? So, but I want to talk about the sort of top end stuff, so let's talk about the world's fastest gaming processor. And if you get to the next slide, I'm assuming, your slide setup are basically very similar to what I sent out. So basically we get to the next slide, which is why frequency matters. And applications are a strange thing, right? Sometimes they like cores, sometimes they like threads, sometimes they like clock speed. So if you can tune your processor to be able to provide all of these things to whatever the application needs, you will get the best application performance, right? So, what we've done here is we've essentially designed these processors to deliver the highest clock speeds possible, and also we have increased the core count on the i9s. We've added hyper-threading to the whole stack, so now we've got more threads. So we're able to actually improve the performance compared to the 9th generation product, but also improve that clock speed as well. But for some applications, it may only use 1 or 2 cores, but they really want that high, that low latency and high clock speed to, get that data through, right? So
and this, especially for gaming, that frequency is extremely important, right? Can you maybe explain why does frequency matter so much compared to, for example, core count, which can help a little bit, but mostly frequency has a bigger impact on your gaming performance.
Absolutely does. And it's about latency. When the game feels a bit sticky, right? We've all experienced that. It's like, oh, why is it glitching here?
A little bit of stuttering and stuff like that.
Exactly, and it's really it's not a very nice experience, right? So by having this high frequency, that can help get that data through. Obviously, if there's other problems on your PC and it's overheating and things like that, then you need to look at those. But in terms of how the product's architected, how the processor's architected, that's where the frequency really comes in.
Okay. And overclocking is also a big topic. Today we're going to mainly talk about B series and H series, but a few weeks ago we talked about the new Z490 chipset, and overclocking is still a big thing for Intel, right?
Yeah, absolutely. So, we've invested in the applications and the tools to make it easier for you to overclock. So the first thing I will say is you can only overclock on the Z or Z platform. Okay, so the Z490, and you need a K processor to do it. Okay, so one with K on the end.
So that one will give you the unlock multiplier, so you can increase the frequency.
Absolutely, yeah, and that gives you also not just that, by the way, it also gives you ability to unlock a whole load of things, including the power and voltages and all sorts of
memory
things.
Speeds.
Yeah, exactly. You can go crazy on it, right? And so we have this application called Extreme Tuning Utility, and you can run this on the board, and basically you can sit there and tune the various aspects you want of your platform. It sort of is the graphical user interface version of BIOS overclocking, but you've got some nice features, like you can see here in this screenshot. We've got the VF curve, so you can actually now change how your voltage is, how it responds to frequency. So the higher the frequency of a processor, you actually can change the voltage ID, the bid, right? And so you can actually change the voltage VRM puts into the processor. So that's quite
later on we will also show a little bit of the XTU, Extreme Tuning Utility. But this differs also per motherboard, right? Because we will demonstrate it on a B460. But for example, this screenshot shows what it looks like on a Z490 motherboard.
Yeah.
And that will unlock extra features also in this program, right?
Yeah, absolutely. And that's how it works. So you can run this application on a lot of platforms, but you won't see all of the whole GUI unless you run it on the Z490 platform with the K processor.
Yeah. Okay. Then something that's also important for overclockers, what you changed in this generation compared to the previous generation, is the thin die on the CPU.
Yeah, absolutely. So this allows us, I've personally been interested in overclocking performance for, longer than I've been at Intel, which is now 23 years this year, right? So
you're a veteran.
it's one of these things that there's obviously a correlation between the heat that the processor is generating and the stability of the overclock, or the ability to get that eat that more performance out. And the more volts you put into the processor, as I'm sure anyone who's tried overclocking knows, the hotter it gets, right? There's a direct correlation between voltage and current and power, right? So if you can actually keep the heat out of the die, because this die is basically a thin piece of silicon. It looks like little pieces of glass if you've ever seen one, right?
So that's basically where the CPU cores are located on the CPU, right?
Exactly, yeah. So in each one of these cores, they themselves are a subsection of this die, and they need to get the heat away from a core, right? And so what you do is by us having this integrated heat spreader, that's the metal bit you see on top of the processor. And then underneath that is this solder material that basically touches the bottom of the die itself, the actual processor, and that then allows the maximum heat transfer between the silicon and the the top of the heat spreader, which then allows you to get maximum heat out of that CPU via water cooling or whatever solution you would have in your system.
So basically, to make the heat transfer from the actual core within the CPU towards your water cooling setup or air cooler more efficient. That's why this thin die matters, right?
Yeah, exactly. You can think of it like, heat is like water, right? So it will travel, and if it's got a nice, fast, easy pipe with no resistance, right, it will go from one point to another. If there's resistance, every time you have an interface, you have resistance, right? So the better you can make that thermal interface between each component, the better your cooling would be effectively, and the lower that temperature would be. And we all know overclockers love low temperatures, right? I've seen people complain about 40 degrees Celsius. It's like, okay, that's a bit excessive, but if you keep it under the 60s or whatever, that's a really good temperature.
And how much of a difference does this make? So compared to the previous generation, to the 9th gen, when you had a slightly different approach to the die thickness compared to the 10th gen, how big is that difference? What kind of difference can people expect in degrees Celsius or percentage?
To be honest, I don't know. I do know our engineers would have worked that out, and but obviously the die is bigger because we've now got 10 cores, or we had 8 on the 9th generation. So there's more to do, and also we've increased the TDP, a maximum TDP of a processor. So it used to be 95 watts for K series; it's now 125. So when we manufacture the processor, we don't do it for like 20 processors, right? We design these things to go into millions, and basically we have to make sure that they're all going to work properly. So we have to make sure we have a very robust cooling solution and an interface material that goes basically between these. So we have to design for all all the sort of corner cases you're going to find, right? And
that's also something we saw in your box CPU coolers, because they changed a little bit compared to the previous generation, right?
Yes, but of course with a K series you don't get a box cooler, so in this particular situation. But to be absolutely honest, I haven't actually seen one of our latest box coolers, because I
saw they were black.
I mainly deal with mobile, but it's if you have one there.
No, we don't have one, unfortunately, yet. So we have to work with the old box cooler today. We will demonstrate it later on. But from what I understood, indeed, the new box cooler offers slightly better cooling performance. I believe in TDP, like from 65 to 80 watts, and it had a cool black color now.
Cool. Okay. Sounds good. Let's go and get one, right?
Yeah. I see some people asking about the giveaway. Yeah, you can join the giveaway at msi.com/2/insider. The bot will also drop a link to the giveaway once every now and then in the chat. So yeah, if you have any questions for Simon, please drop them in chat as well.
Someone asking about pricing, but that will be in
later on. I believe Simon will show an overview with all the different LGA 1200 CPUs, and also
the
with
motherboards,
the pricing included. So that will be shown later on. Okay, let's talk a little bit about Intel Turbo Boost Max Technology 3.0, because we know Intel Turbo Boost technology, but that's changed a bit over the years, right? Because Turbo Boost has been existing for maybe over 10 years now, but it's evolving every generation basically. So maybe you can explain a little bit about how does the Turbo Boost Max technology work on the 10th gen Intel Core CPUs?
Yeah, sure. So we've got this new feature called Turbo Boost Max Technology 3.0. And actually, if you ever looked at our X series products, we've had it on that for the last 2 generations. But it's the first time it's come into the more mainstream core processors. So with this, with our Core i7 and Core i9 only, what we can do is, so Turbo Boost 2, essentially all the cores could go to the maximum turbo frequency, okay? With Turbo Boost 3, what we've done is some cores can go even higher. So what we've done is the processor itself can actually work out which of those cores that can clock even better, and actually
because there can be a slight difference in between cores, right?
There can, but when we specify the product, if it's a Core i9 99, 10 900K, you're going to get 5.3 gigahertz, right? It's so yeah, but it's not like one of them will get 5.3 and your friends will get 5.1 or something. No, they're going to meet that minimum requirement. But the processor itself will decide which cores it's gonna really crank up to the next level. So
basically it selects like what are the best cores in this CPU, and
yes.
those will be increased in frequency even higher than the regular boost frequency of
exactly.
the CPU.
Assuming, and again, this is when the thermals come in and the power, assuming you've got power budget and thermal budget, and then these processor cores will, kick in another level, right? But you can't guarantee it's always going to be Core 0 and Core 4 or something like that.
So on CPU A it might be Core 4 and Core 6, and on CPU B it might be Core 2 and Core 8, for example.
Yeah, exactly. But they will meet the same specification. So I just want to make that very clear. But you're not going to go, oh, this one doesn't get to that clock speed. No, that's not how it works. When we put the specification out there, the processor will get to that clock speed.
Okay, I see. Let me see. I just saw a question in chat. Let me quickly scroll up a bit. Aaron is asking what CPUs will be supported on the B460 chipset.
From a chipset perspective, we support all of the 10th gens, but from a motherboard vendor perspective, you might want to be more specific about which ones will work with a VRM solution you have.
Yeah, so like theoretically, every LGA 1200 CPU, so every 10th gen Intel Core CPU, but also the Pentiums and the Celerons from this generation will work on a B460 chipset. And of course, it will matter per motherboard. If you have a more entry-level model, then it's not advised to pick, for example, the most high-end SKU of the Core i9, and the other way around. If you have a very high-end B460 motherboard, so one of the top models, then it doesn't make sense to go for a Celeron, for example. You would usually go for an i5 or even an i7. Yeah, let's continue to our next topic, because you already touched on this, the world's fastest gaming processor, the Core i9 10900K. So what makes this CPU so special compared to the top model from the previous generation?
Yeah, sure. So as I said, we've added 2 more cores to the product, although cores aren't absolutely necessary for maximum game performance. Not all games really scale with huge number of cores.
And that differs a lot per game, right? How much you benefit from more cores.
Yeah. So there's some out there like Ashes of Singularity that really go with cores, but there's others which don't really scale beyond 4. So you can essentially look at it yourself by just run a game on your PC, and if you run it in a window and have a look at Device Manager and see how much CPU utilization it's using. It's always an interesting thing I do in the lab, right? But you can have a look at just how many cores you need. But it's that clock speed. That clock speed really drives this that low latency, and it's the latency is a bit you feel with the games, right? So and also if you want to run high frequency displays, as more and more people are going 144 plus hertz, there's always an argument, 60 FPS was enough, but now like you need 144, 240, 300, right? So you need to be able to drive your video card to do that, and the video card's capable, but it's needs that data fed through the PCI Express and all the rest of the platform. So basically all this, not just the processor, but all of the components of the system have to work together, right? So all the interfaces, everything. So it has to deliver that sort of flawless data transfer, and that's sort of what we bring. And this is the with all our range of products, but this is obviously the ultimate, this i9 10900K.
And that's always a little bit interesting with gaming. You expect like the higher I crank up my settings. So for example, if I play at the highest resolution with the highest setting, then it's necessary to have, for example, a Core i9 CPU compared to a Core i5. But it's actually interesting to see that when people are playing with competitive settings, so to say, so in like CSGO or something, many people play in 1080p with a high refresh rate monitor. And actually, the higher your frame rate gets, the more important your CPU becomes relatively, like compared to your GPU. So especially if you want to play those esports titles with a very high refresh rate, then you really want one of those very high frequency CPUs to be able to keep up with the frame rate. Whereas if you play on a very high resolution, your load will shift towards your GPU more. So then, as a matter of fact, it doesn't have as much of an impact as when you play at competitive settings. So that's always kind of interesting to see, because it's quite a common misconception that people think it doesn't matter because I play at low settings and at a low resolution, but then your CPU will matter even more, basically.
Yeah, absolutely. That's and another thing as well, if you want to stream and record, then that's going to use some resources of your system at the same time. But obviously you don't want to impact your game performance, because the last thing you want to do is stream you performing really badly, right? So, that's a game where having these extra cores actually helps, because, it keeps some of the Windows tasks and the streaming tasks away from the actual game task as well.
So like in gaming, for example, you will often not see that big of a difference in between multiple CPUs, like whether you go for an i5 or an i7. But if you want to do streaming at the same time, then those extra cores will make a bigger impact, right?
Absolutely, yeah.
Then let's talk about the new technologies within your CPU, because you have not only added more cores, but also the memory frequency increased. You made some changes on the cache. You also had added hyper-threading to a series of CPUs that previously didn't have hyper-threading. Can you maybe tell a little bit more about that?
Yeah, sure. So I mentioned about the Turbo Boost 3. So, it's headline top speed of 5.3 gigahertz with Intel Thermal Velocity Boost. Interestingly as well, I know we're not talking about mobile, but that's my day job. The mobile top-end processor also goes at the same clock speed, up to 5.3. So, we've got the whole 10th gen family going at this speed, right? We've also got hyper-threading across all of the products except Celeron. So Pentium, Core i3, Core i5, Core i7, they all have hyper-threading now. And so the main difference between all of these products is the Celeron is a dual-core processor with no hyper-threading. Pentium is dual-core with hyper-threading. Core i3 is quad-core with hyper-threading. Core i5, guess what? 6 cores with hyper-threading. Core i7 is 8 cores of hyper-threading, and Core i9 is 10 cores of hyper-threading, right? So, it's quite simple to work out between the different brands how many cores you're going to get. And as I said, we have hyper-threading on all of these. With the extra cores comes extra cache. Interesting thing about Intel's Smart Cache is that's shared across. So if one core is just doing all the work, it can have 20 megs of cache, because this cache is shared amongst all the cores, right? So, and with the 10 core part, we've got 20 meg. It works out roughly at 2 meg a core, but it's the way we've done it is it's a shared cache.
And how will a user benefit from hyper-threading and that extra cache? What will it do directly in terms of performance?
So some of the background tasks that happen, your PC's doing, it's busy all the time, right? Doing all these things. The hyper-threading always sort of helps a little bit of these background tasks. And also, if you're doing something that is heavily threaded, because a modern processor is very complicated. It's like lots of little processors, and the hyper-threading can basically allow the software to run in different parts of the processor simultaneously. Because if you've just got one thread going through, then it may not be accessing the floating point unit at the same time it's accessing the ALU, arithmetic logic unit, right? But if you've got hyperthreading, you can access both at the same time with 2 different threads, right? So that's how it works.
So also, for example, if you're gaming, sometimes people like to run things on the side, like for example, play some music on Spotify or a program like that. That's also what will go easier when you have hyperthreading, right?
Yeah,
it will have less of an impact on your CPU.
These sort of lightweight tasks, but they just sort of like find like a cyclists finding their way around the traffic, right? So yeah, it's sort of like these tasks. Always helps with hyperthreading with that sort of thing.
And also with heavier workloads, right? Because that's where it really makes a difference.
Absolutely.
Like if you're also, nowadays more and more gamers are also doing content creation.
Yeah.
So for example, we already mentioned streaming, but also making videos for YouTube, stuff like that. And then if you're going to render a video, then you will see a huge difference, right? If your processor has hyperthreading or not.
Yeah. That's absolutely right. DDR4 support 2933. You might think, oh, we've had 4,000 support for years. Well, that's using XMP. So when Intel talks about the DDR4 support, they're talking about what we call the JADEC spec, the sort of the plain specification, the green DIMM.
So like the native support, basically, right?
Exactly. So that's a native support. So essentially, that's your baseline support. And then if you want lower latency and other features like that, then the board vendors like MSI, will basically support the extra high performance memory by laying out the board and adding the BIOS support in.
Just quickly interrupting, I see a question in chat from Edwin. He's asking on which budget Intel CPU can you game optimal? So what will be like a good budget pick in the new Comet Lake S series for gaming?
But that's a really good question. I was actually looking into this because people ask me all the time, oh, what would you build? And it depends on your budget, obviously. So the K series are fantastic, right? So don't get me wrong, they're great products and the pricing spaced apart. So you can pick up a Core i5, 10600K, and in the UK it's about £100 different from a Core i7, which is about £100 different from a Core i9. Okay, but if you want to spend 160 euros or whatever on the CPU, then we have this one called the Core i5 10400F. Okay, you'll see, we'll list the pricing, but this is an excellent processor for that sort of, more budget-conscious purchase, right? And
so if you're not into overclocking and you don't need, for example, the memory, faster memory and stuff like that, then, for example, the 10400 or 10400F. Later on, we will go into the differences. That will be a right pick, you're saying.
And absolutely, and that would go along with, say, a B460 type motherboard. So and I'm sure you'll talk about your range of B460s later
Definitely.
on. So, there's a great match, I think, with a few of those. But there's, going through this list and coupled to what we're just talking about, there's other things like, integrated Wi-Fi 6 support, for instance. So you might think, oh, why is that important? Right, it's a desktop. But I don't know about
maybe you can show the mortar, because we actually have a model right here laying, so we can show how people will see this.
Yeah.
I lost my ear.
Your ear or your earphone?
No, my earbud, sorry. I cannot hear Simon anymore. Okay.
Can you hear me now?
Yeah, we can.
Okay, cool. Yeah. So the Wi-Fi 6 support, you might think, oh, why do I need Wi-Fi 6 on a desktop? Well, I don't know about you, but I've been working at home now for 3 months, right? And I've moved my office around a couple of times. Now, to run an Ethernet cable around the house, although that's obviously, traditionally the best way of getting any network going, other people in the house weren't so pleased with me drilling holes through the walls, right? So having Wi-Fi 6 means I can have low latency, high-speed connection via wireless. I'm actually streaming this right now on a Wi-Fi 6 connection through a repeater, which is Wi-Fi 6, through my access point. So, if this stream is coming out okay, then Wi-Fi 6 works pretty well, right? So
yeah, we have like the same. Also, because of the current situation, we try to work from home as much as possible as well. And it's been going on for a couple of months now. So I also have like a dedicated place where I can work now. And usually I have LAN cables all around the places where I have computers or other devices to have a cable connection. But of course, because this is a temporary situation, I don't want to have a dedicated cable all the way to my temporary working spot. So that's also indeed something where I use Wi-Fi.
Yeah, exactly. And also gives you more options. You might want to put PC somewhere where you haven't had it before, right? So again, you don't want to necessarily route some cables around the house. So this is all good things. There's a couple of things as well which are interesting and featured, and we've had them on previous gens, but it's always good to point them out. So Thunderbolt 3 support, for instance, it's a Intel technology, not an Apple one, right? So basically, it means that on your PC you can have Thunderbolt, and so all those peripherals that you can get, but you might think are exclusively for an Apple ecosystem, actually are not, and they will work fine on most of them. Fine on Windows. Check the drivers and everything from manufacturer first before you quote me on that. But most will work with Windows, and there's some boards here with so MSI has some boards with.
Yeah, so for example, we have it on our MEG Z490 Godlike has 2 Thunderbolt ports, and also the MEG Z490i Unify, so the ITX model, also has a Thunderbolt port integrated on it. And it's a quite interesting port because it can do so many different things, right?
Yeah, absolutely. So it's not just, you may realize that you can add like an external graphics card in there. If you've got a mobile system, that's great. It gives you that sort of, you can get a desktop video card attached to it effectively. But also you can do other things, like you might want a localized storage array. So I'm seeing devices coming out all the time which essentially give you very high speed storage, and using PCI Express SSDs, for instance, things like that. Also monitors, things like that. You might think, well, why do I need a Thunderbolt monitor? Well, it has a Thunderbolt sort of throughput, so basically you can connect it.
So basically it's carrying like a DisplayPort signal, right?
Yeah, absolutely. So it's a DisplayPort, but also you've got the data, and also then you can plug other devices into the back of your monitor. So you can have a much cleaner desk setup, right? Again, quite important, if you're looking around. So, at different things, and you plug different things into your PC. In the case of a desktop PC, your PC might be under the desk, right? You don't want to keep going in down there and plugging things in. So by having essentially a dock on the top, you can then plug things into that. And then we got Intel Optane memory, which essentially is this high-speed sort of. It's I've been describing it for years, and I suddenly blanked on. But anyway, it's a new kind of non-volatile storage memory. Okay, we've been selling it for 3 or 4 years. Some of you might not think it's that new, but some might be new to this. And it's sort of, its performance and latency is more like DRAM, but it doesn't forget when you unplug the power, right? So it means that
so it's not temporary.
It's not temporary. Yeah, absolutely. So this technology is very interesting and allows you to speed up slow disk accesses. So you can speed up mechanical drives. You can speed up even SSDs with it. So it's essentially supported in the chipsets up to the B460.
Okay. Let's talk a little bit about real world performance, because that's basically what matters to someone who buys this kind of CPU. You made a bit of a comparison between the previous generation, but also a PC that is 3-year-old. So I believe that this was tested with Core i7 7700K, right?
Correct. Yeah.
So that's a Kaby Lake CPU. It's around 3 years old now, but it's only a 4-core 8-thread CPU. That's basically what you now have on i3, I believe.
Yeah, absolutely. And actually, the i3 is a high frequency, so it's actually even faster than that 7700K. So yeah, it's that demonstrates, this is this year-on-year thing we were talking about. So Intel's philosophy is we want to deliver better performance every year, okay? And it doesn't necessarily matter how it's made. We just have to deliver better performance. That's essentially what our design engineers and everyone working in that side is delivering, and we're delivering on this. So you can see here on these numbers. So, okay, there's 5 particular cases here, but obviously, there's hundreds of different variations.
So these are just a couple of examples where it gives you more performance.
Exactly. So compared to that 3-year-old PC, which 7700K, if you're still running one of those, it's a good system, right? But you can get like 81% more performance with this 10900K. You might say, well, that's an i7. You compare it to i9, but actually we didn't have i9 in that space on the.
So it's basically comparing your top-end model on the mainstream platform from that generation to the top-end model on the mainstream on this generation.
We only had i9 on the X series in those days. And then compared to even last year, so that's the 9900K.
So that is a Core i9?
The Core i9, that is a Core i9 to Core i9, 33% performance increase, right, on this particular game. Right, and then this is also looking at the sometimes they're streaming as well. So in these particular cases, like PUBG, that's that example of streaming and playing as well. So we've got 10% compared to 9900K and 63% compared to the 3-year-old PC. Right, these are big numbers, right, and we're able to deliver this.
And also when we're comparing, for example, the 10th generation to the 9th generation, so 10900K to a 9900K, in this overview we can basically see 2 things, right? Because on one hand you get better gaming performance, which is mostly due to the higher clock frequency, and on the other hand we have like the example of Adobe Premiere. The rendering will not benefit maybe as much from the higher frequency, but more from the additional cores. So you're basically winning in 2 segments compared to the previous generation.
Yeah, absolutely. And there's another little thing as well, but you may or may not realize, if you buy the processor without the F, so that will have graphics in. And you might go as a gamer, well, I don't want to play on Intel graphics. But it does a bit more than that. So inside that graphics engine is something called QuickSync technology, okay? And QuickSync video is a feature. And this actually allows you to accelerate some encodes, even HEVC encoding, using that QuickSync encoder engine. It's also a decoder as well, which can actually, create examples of really good encode performance for that final render when you want to, compress that video down to something you can share with somebody else.
I see a question in chat. What will be good for video editing? And is a good game laptop also good for video editing?
That's an interesting question. It's for video editing itself. You sort of want to go as high as possible. That's always been the general advice, right? Inside your budget,
because they're usually like the programs, video editing programs like Premiere, they're able to utilize much more of the CPU power than many games do, right?
Exactly. But also, as I just mentioned about this QuickSync video technology, you're also able to leverage some of this as well. And also, if your graphics card, it would do a certain amount of acceleration as well. So, gaming, and traditionally, and it's interesting. Person asked about the gaming laptops. Yes, that generally the gaming laptops were seen as sort of like creator laptops or almost workstation type laptops. However, in the last couple of years, the manufacturers have started focusing on, and MSI, you have a great range of prestige laptops, right, which basically have the content creator in mind. So they've got tuned panels. Because the other thing you have to remember is, what you see on the screen is obviously very important, because you're
that's indeed something that
right?
was a big difference in between, like when you get a notebook, you, for example, get a high refresh rate screen, but in that segment, color calibration is not as important as the speed for
Exactly.
competitive gamers.
Yeah.
But on the other hand, the content creator doesn't really care about a high refresh rate usually, because most of the content nowadays is produced in maximum of 60 FPS. So a 60 hertz screen will already do, but they do care a lot about the color grading of their videos or their images, so color accuracy becomes a way bigger topic.
Yeah, absolutely. And as I said, I think MSI have a quite unique product, a micro LED screen, which is like, the screen is really, you want the performance, but you also want the interface as well in terms of a laptop.
Small teaser, later in a future stream we will go deeper into this, also about this specific notebook. But now let's continue for desktops. Because you're also, of course, partly the speed increase comes from higher frequencies, more cores, but also optimization, right? Because you're working with different partners also to get this improved a lot more from generation to generation.
Absolutely, yeah. And I will say, as long as I've been at the company and longer, the hardware is one piece, but the software is another piece, right? So Intel works with the whole software community, and there's a lot of tools out there. If you look, Intel has compilers and all sorts of performance tools that you can do. And it's more than just the PC. There's a whole world of devices that you don't have an interface to, which are connected to the internet and run all sorts of things, right? So, but going back to this PC area, there's obviously having the optimization both for the CPU to make sure that the game engine is optimized, which means then if we work with a game engine developer, it means that all the games developed on that engine are also optimized as well for the latest processor. And that means it's using the latest instruction set, it's making sure it doesn't stall on certain threads and whatever combination. There's all sorts of things that the software developers need to sort out. And we have a lot of engineers working within Intel who actually look after these accounts to the level of looking at the code and really optimizing at a sort of binary level, which is still something that's done, right? So it's impressive stuff.
Okay, let's take a look at the CPU lineup, I think, because I see many questions about all the different types of CPU and when should I buy which CPU, basically. But to get a better understanding, of course, we need to know the differences between all the CPUs. And it's quite a list when looking at the 10th gen Intel Core CPUs. Yeah. Because I know a couple of generations ago, it was a way more simplistic list, but there was not as much to choose from.
So, choice is great, as they say, right? So, obviously, I mentioned earlier about the F and the SKU. So the F SKU, if you see an F on the end, means it has no integrated graphics, okay? So if you're purely looking for discrete only, it might save you a bit of money to buy an F SKU, especially in the Core i5 range, for instance, where you're going to definitely put in a discrete graphics card, okay? So although the integrated graphics can do some other things, like, as I said, with the QuickSync video, it can do...
So, for example, if you would do gaming and streaming, then it would make sense, for example, to go for the non-F part. Absolutely, with the integrated graphics.
Yeah, absolutely. And by the way, you would need to turn that on in the BIOS as well, right? So you have to, normally it's the default to have it to integrate graphics is switched off as soon as you plug in a video card. So you need to go in and turn it back on in the BIOS to actually access that graphics engine. And in Windows, you'll see two, right? You'll see whatever your main graphics card is plus Intel UHD 630 graphics.
So you can use your a discrete graphics card for rendering the game, and you can use the integrated graphics simultaneously to encode your stream.
Yeah, absolutely, absolutely. And one gotcha, make sure you plug your monitor into your graphics card, okay? That's confused many an intern who's come into my lab. When he first arrived, going, well, that's not why I'm not getting a video output out of this.
That's some good advice indeed.
So yeah, it's what we got here. The K means fully unlocked, okay? And
so that's for overclocking.
And the one without any letters after the end is the sort of more mainstream part. It's maximum 65 watts. It's mainly designed for system integrators, but also systems you might buy off the shelf. Also business systems as well would use the ones without the letters on the end, right? So that's typically what they're used for. There's nothing stopping you building a PC out of it, by the way. You know, that's it's still a very good processor for everyday use, right? So.
And we also see one of your latest technologies here, and that's the thermal velocity boost. Can you maybe explain a little bit more about that?
Yeah, sure. So that's related to that Turbo Boost 3 technology, where thermal velocity boost essentially is the processor will go to its maximum clock speed when the CPU is under a certain temperature. And if you look at the spec sheet, so it's actually written in the small print down here, below 70 degrees Celsius, and there's enough power budget available, i.e. you haven't used up all of your TDP, then the processor will overclock to this thermal velocity boost frequency. Okay.
So previously, a better cooler would only give you lower temperatures, but now a better cooler will also give you better performance.
Exactly. Yes. Yes, absolutely. So if you can keep your processor under 70 degrees Celsius and you've got enough power budget available, which the motherboard can take care of, then you can potentially run this product a lot faster for a lot longer, right?
Mm-hmm. With the i7, we of course see the major change compared to the previous generation, the addition of hyperthreading.
Absolutely, yes, and we're up to 5.1 gigahertz. We had the KS that came out that could do an all-core turbo of 5 gig, but now we've that was an i9 obviously, but now we've got up to 5 gig in the i7 space on 8 cores. So you can probably do the maths, right? You can see that those parts are very similar, and you'll get that sort of level of performance out of the i7.
I see a question in chat. Which socket is the processor using, and is it compatible with 9th gen Intel processor after BIOS update? That's for the motherboard side. No, these CPUs are all LGA 1200, right?
Yes.
So it's a new socket. This is not compatible with, for example, a 300 series motherboard, also not after BIOS update. Later on we'll also show you more of the details why it's also physically not possible to run the new CPUs on an older motherboard or vice versa.
The good news is though the cooler placement holes are in the same place, so you can still use the 1150 type heat sinks.
So also if you, for example, invested in an expensive water block for a custom water cooling rig, you usually can use the same water block from the 9th generation towards the 10th generation.
Yeah.
Then let's continue with the i5 and i3 parts. And here again, we can already see a big change for the compared to the previous generation with the thread count, because also hyperthreading.
Absolutely, and we've also got 6 cores. We had 6 cores in i5 space before, but now we've got, we've now got the hyperthreading, so we've now got 12 threads where we had 6 before that. And with the i3, we've now got 4 cores with hyperthreading, and you can see here the maximum frequency on the i5. We go up to 4.8 and the 10400F, someone was asking about earlier, that goes up to 4.3. Very capable processor still. So obviously doesn't hit that headline speed of 5.3, which is a whole gigahertz up, but it's considerably cheaper, right? So if you look, there's a pricing at the other side here, $157, which is sort of in the same sort of price range as these upper i3s. So but those i3s have integrated graphics, and also, as I said before, they were sort of tend to be used for sort of off-the-shelf PCs, but also for business PCs as well.
See another question in chat. Can you overclock with the standard Intel cooler?
Yeah.
Well, the overclockable CPUs don't come with the Intel box cooler. So if you buy a K SKU, then we would, in general, advise to go for a beefier cooling solution. If you're going to overclock especially, of course, it depends very much on which K CPU you buy. So if you buy a K SKU i5, you don't need as extreme of a cooling solution as a K SKU i9, obviously. But in general, if you're going for a K SKU that you're probably going to use to overclock, then, for example, an all-in-one water cooling would be an interesting solution.
Definitely.
And that's also the reason why you're not bundling a stock cooler with the K SKU, right? Yeah.
So a very long time ago, we did, and I've got some examples in the lab of some CPUs we did bundle effectively the first of the K series. We did bundle with a heatsink. Then we found that most people just were throwing them away or putting them on eBay, right? So basically, it was a lot of hassle, and we were shipping these massive boxes, and they're really heavy, and essentially, the cost was just being passed on. So by us taking it out of the box, it does save cost, it saves shipping weight,
I think I still have one laying around because I did exactly the same. I also had a K SKU, but I used a different cooler setup. But that was like back in the Sandy Bridge days, I think.
Yeah, exactly. Yeah. Back in the dark ages, right? Yeah.
Yeah, but like in the past generations, there was no box cooler included anymore with the K SKU. Okay, so let's continue to the next segment, the Pentiums and the Celeron segment, and this is more of the entry-level segment, of course. But for example, very interesting for like a home theater PC or an office PC, like an internet computer, stuff like that, right?
Yeah, absolutely. There's still need out there for people who just want a basic PC. They don't necessarily want a mobile. They want a keyboard and a mouse and a big screen. I know you can plug them into a mobile if you want, but essentially, this still gives you the best, use that phrase, bang for the buck, right, in terms of performance to price ratio. So having this Pentium Gold or Celeron processor will still give you a great sort of Intel experience. You've got processor graphics on here. You even got the QuickSync video. By the way, these processors can decode HEVC 4K, right? So you can even watch Netflix 4K on it if you really want. If you connect it to a 4K screen. Yeah, there's all of these sort of ability inside the processor. But coupled this with the H410 chipset, you could have a great media center, or you can make like your own NAS or whatever. You could use FreeNAS or something, plus you've got four SATA ports normally on the motherboard, so you can get a few external drives. And you can run something, I do at home. I run a Plex server on it, and I can get all my media on all the devices. And you can even put a TV tuner in there, and you can stream your own TV from your house. Now, I haven't traveled anywhere recently, but when I was all over the place, and it was very handy. I could catch up on my TV without worrying about. Or basically I can just set it to record or whatever, just free to air TV.
I have a question here from Mr. Masterdax. He's asking, why does i5 have lower clocks than i7 and i7 lower than i9, while they have fewer cores, which should mean there is more room to clock them higher than the parts with fewer or with more cores. So basically the question is, why is i7 clocked higher than i5 and i9 clocked higher than i7?
Yeah, sure. Well, obviously, we sell the products at different price points. So, it is a feature of a product, and essentially we charge more for the i9 because it's more capable than the i7 in terms of, the out-of-the-box specifications. When it comes to the K SKUs, for instance, the i9 is on the best silicon. So, when the silicon's made, the processor or the core clock speeds can vary, right? So test them all, and the ones that are best. And by the way, it's like a bell curve, so it doesn't, it's not like a linear thing saying you'll get 50% of this and 10% of that, whatever. There is a percentage, and the best die, which are the rarest, right, basically end up in the best products, and that's how it works, and why some are more expensive than others.
And that's also why, for example, they can reach higher clocks than a Core i5 part, even though in theory they produce more heat because there's more cores, but because the silicon quality is better, they're able to achieve those higher frequencies.
Yeah, absolutely. So it comes, and when these products are decided, there's a lot of thought goes into exactly in testing exactly what we can offer. Obviously, we want to bid offer as much as possible, and that's why we have like the different brands and what they mean, and the different price points. The Core i5 is half the price of the Core i9, but you're still getting 80% of the performance. So it's
and also, if you have the i5K SKU, then you can always try to see how far you can get it yourself.
Absolutely, yes, yeah.
Okay, I saw another question. Is there no i3F variant? So let me go back to the i3 page. No, I think they all have integrated graphics, and I think when I assume the reason for that is people that buy a higher end CPU are more likely to also use a dedicated graphics card, right?
Absolutely. So our strategy is for gaming, we recommend Core i5 upwards, and so and that's why we put the Core i5 10400F as our entry level Core i5, which is a great price point product. It's $30 cheaper than the one with graphics, right? So that's quite a lot towards your external graphics card. And that's essentially the Core i3s are.
And also, when we look at, for example, the Pentiums and the Celerons, you also see those always come with integrated graphics, because many people that will buy these kind of products, for example, for a home theater PC or a simple internet PC or a NAS, they don't need a dedicated graphics card, so they will use the integrated one.
Yeah, absolutely. And the Intel UHD graphics, as I said, can provide 4K, multiple 4K displays, decode HEVC video flawlessly, no glitching or weird artifacts you sometimes see if your device is not capable of doing it. And also, you've got great energy efficiency in doing that as well, because the integrated graphics uses less power than having a discrete solution. Plus, also it's cheaper, right? You don't have to add this extra card into this.
And less power is also less heat, and you don't need as much space. So you can get, for example, like a home theater system, you can make it way smaller when you would get something like this.
And you can put a smaller power supply in. There's less fluctuation in the power requirements, so you can have like a 160 watt power supply, right? You can buy some small chassis with that. So
Matt is asking, is the i5 10400 should be better than the 7700K, right?
I am pretty sure. Yeah. Well, firstly, it's got 6 cores as opposed to 4, right? So and the clock speed. Obviously, with 7700K, you can overclock, but the i5 10400 goes up to 4.3. It's not overclockable, but that's still a decent clock speed to play with, and you'll get some good gaming performance out of that.
So yes, in most situations, like unless you overclock the hell out of that 7700K, but in common situations, an i5 10400 should be quite a bit faster than the 7700K.
Yeah, absolutely. Yeah.
Yeah. And then you also have the T-SKU CPUs. Maybe you can talk a little bit about that. What is the difference between T added behind the name compared to the F, the K? We talked about all those. But T is a little bit different, right?
Yeah, sure. So T is the 35 watt thermal design power component. So T on the end typically means that it's designed for either a very small form factor system where you are going to struggle with the cooling. So you put this processor will only run at 35 watts maximum. By the way, TDP is a maximum number. It doesn't mean if you get like a K, it's 125. It always runs 125. Basically, it's it goes up to it. So it's like a speed limit. It doesn't mean you have to drive at it all the time or exceed it. You basically, it's a maximum. So the maximum power consumption of these Ts is 35 watts. Unless there's something called configurable TDP that allows you to change it slightly, but let's just say nominally it's 35 watts. And they are typically used in like all-in-one PCs where your cooling solution is potentially limited, and so it's sort of think of it almost as a socketed mobile processor because it's a similar sort of specification to the mobile processor, but it's in a LGA 1200 socket, so you can put it in a standard motherboard, and you can get decent performance, but at 35 watts.
And this is what you will mainly find, for example, in pre-built very small systems, like you mentioned, all-in-one computer.
Yeah.
But this is not a type of CPU you will find in every regular store around the corner, right?
No, not at all. A lot of professional, so business PCs would use something like this, small form factor, something you might find at work on the desk, one of those tiny desktop PCs that would typically have this sort of processor in it.
Okay. Simon, thank you so much for all your explanation, and thanks for answering all the questions that came from the chat.
Well, thank you very much for having me on your live stream.
It was a pleasure to have you.
Okay.
And hopefully we'll have you again in the future to talk about future generations.
That'd be great.
Hey, have a good evening.
Okay.
Bye-bye.
Bye.
Thank you. Bye-bye.
So that was Simon from Intel to talk about the new 10th gen Intel Core CPUs, also about different chipsets like Z490, B460, H410, all compatible with, of course, the new LGA 1200 CPUs, Comet Lake S CPUs from Intel. But now let's get further into the motherboard side of things, because of course to run one of those CPUs is not possible to run them on a 300 series CPU or a motherboard, so you will need a 400 series motherboard to be able to run this. And of course the Z490 it's like the flagship chipset from Intel, and it is an awesome chipset, but of course it's more expensive than your cat was in front of me. Yeah, I'm not physically sitting next to it. No. It looks like it, but yeah. I'm not, of course, because of the corona situation. But yeah, if you don't care about overclocking, for example, if you don't need the most extreme models in the 10th gen core lineup, then, for example, an H410 or B460 motherboard can be quite interesting. So let's dive a little bit into those. Maybe you can already give a sneak peek, Ruud, about some of these models.
Which model do you want to show first?
Let's give a sneak peek from Tomahawk.
Tomahawk,
I think
okay.
People generally like that model.
Okay. I can show you like this, or I can show you a little bit further away.
The MAG B460 Tomahawk.
So this is the full ATX one.
Yeah. We also have many micro ATX model, and in the future we also have some ITX models, which I will tease a little bit later on in the live stream. People in chat are responding, stop stealing his drink.
Yeah.
Well, as a matter of fact, I have my own drink right here.
Yeah, but I can put mine next to it.
My can is a little bit bigger.
That's a little bit weird. Yours is bigger. Weird.
Exactly.
It should be from the same
I
machine.
have to put it a little bit higher to have it in the screen.
Anyway. Okay.
Yeah, so let's take a look at this. So like I mentioned, if you have a 300 series motherboard, so for example H410, B460, B365, Z370, Z390, they're all compatible with both Coffee Lake S, so the 8th gen Intel Core, and Coffee Lake S Refresh, so the 9th gen Intel Core CPUs, but they're not compatible with the 10th gen Intel Core CPUs, so Comet Lake S. Then you will need socket 1200 motherboard, so LGA 1200. All our motherboards, they come with Core Boost technology, so they have a premium power design, also to be able to extract maximum performance from these kind of CPUs. Later on we will show the power design in much more detail. But what it essentially means is that even though the processor is not overclockable, it still has certain boost frequencies. And later on we'll also demonstrate you how on MSI motherboards you will get more performance, because the motherboards will be able to boost these CPUs for longer periods of time at a higher power draw, and essentially giving you more performance. So even though the non-KSQ CPUs, they have a 65 watt TDP, or Simon just talked about, by unlocking certain power limits or by having higher power limits, you can extract more performance from this. So we will dive into that later.
Yep.
Of course, if you're going to increase the speed of your CPU and increase the power draw of the CPU, you will need better cooling. So that's why we have extended heatsink design on many of our B460 models, so like the Tomahawk, the Mortar Wi-Fi, the Mortar, and the Bazooka. So maybe we can show one up close.
Which one you want to show? The
Mortar or
Mortar.
Tomahawk.
This is the,
yeah. So here you see that on top of all the way to the I/O shield, you see that there's one big heatsink.
Yeah.
And by having a bigger heatsink, you will get more space, basically, to more surface area to dissipate the heat. If you can turn it to the side a little bit, you can also see that it has some fins right in there, and that's also all to enlarge the surface area. So it will be easier for your motherboard to dissipate the heat.
It's quite heavy as well, so there's a lot of weight to it.
People are asking, are you guys allowed to comment whether you prefer Intel or AMD? Yes, of course, I can tell whatever I like best. But as a matter of fact, I don't have a clear preference. It will be strictly based on what I would build that specific system for. Because Intel has their strong points, AMD has their strong points. AMD is more on the many cores for a competitive price. So for example, if you're doing a lot of rendering stuff, if you want to reach a certain price point, you can probably get more rendering performance out of those, whereas Intel is usually has a bit higher clock frequencies, and they tend to give you a little bit better gaming performance. So it would very much depend on the system I would be building at that point, what the purpose of the system is, what I would choose. So it's not that I have like a specific preference towards Intel or AMD. I also saw some questions in chat about when people can expect X570 Tomahawk. It should be out in most regions, so check with your local retailer. If it's not available yet, it should be available very soon. Apart from the cooling solution on the VRM design, all our B460 motherboards also come with M.2 Shield Frozr. And M.2 Shield Frozr is the cooling solution on the M.2 slot. And with NVMe SSDs, they're getting faster and faster, but also the controllers can heat up a little bit. So cooling becomes more and more important on your SSD. And if your SSD gets too hot, it can thermal throttle, and especially because an SSD is so near to your graphics card, also the graphics card can heat up your SSD. So that's why additional cooling for your SSD in certain situations can be really beneficial for the performance of your SSD. So maybe we can show the M.2 shield frother on one of the motherboards.
Yeah, of course.
So you can easily, it's only 2 screws, you can easily screw it off, put your SSD underneath, put 2 screws back, and that's basically it. So very easy to install.
There's also a thermal pad on the
so there's a thermal pad underneath. There is a little piece of plastic on there, so make sure to take it off before you install it, because otherwise you will heat your SSD instead of cooling it, which is not what you want, of course. All MAG series, so our gaming series, Arsenal gaming series, come with 2 M.2 slots. So storage is moving more and more towards M.2. It's also a lot faster than SATA storage. SATA SSDs easily get bottlenecked by their interface nowadays. So basically all modern SATA SSDs are all approximately the same speed, because it's just the speed that SATA can deliver. So if you want a faster SSD, you want to use the PCI Express interface, so you want to get an NVMe SSD. But for example, when you buy a 500 gigabyte SSD right now, in a couple of years, maybe 2-3 years, games are getting bigger and bigger, and you don't have sufficient space anymore. Instead of having to replace your old SSD, you can simply add a second SSD into your motherboard on those B460 MAG series motherboards. And for example, here we see the MAG B460 Tomahawk, and there you see that there's also a difference in the maximum length of the SSDs that you can put in there. 2280 is basically like the standard length that you see nowadays on most of the SSDs. Some are smaller, of course you can always use the smaller SSDs in these slots as well. But you cannot, for example, use a 22110 SSD in a 2280 slot, so then you will need a bigger slot. Right now they're extremely rare, so most are still 2280. But in the future, when we go to higher capacity SSDs, it's also possible that the size needs to increase to accommodate all the memory chips. So just to be sure that you can always accommodate even a 22110 SSD, the top slot is a longer slot in this situation. So your question, so AMD should be better for rendering and video editing than Intel. It very much depends on which exact CPU you buy. Like a Ryzen 3 CPU will not be faster in rendering than a Core i9. But if you're looking at the price point, at the same price point, usually the 3rd gen Ryzen CPUs will give you a little bit more rendering performance, whereas the 10th gen Intel Core CPUs generally give you a little bit more gaming performance, and that's mostly because AMD offers more cores at that price point, whereas Intel offers higher clock speeds at that price point. So it really depends on what you want to do with it. So another question, what's the cost of the Tomahawk? We will talk about the prices later on. We'll show you the prices of our complete H410 and B460 lineup. 22110 or some Optane Accelerate SSDs, exactly, there you can find them. And in the future, maybe also for normal SSDs, they get more common. So just to be sure, there is a slot on there. So B460 is the equivalent of B450 of the test. No, those are very different chipsets. They sound very similar, but they're very different and very hard to compare. Also in terms of course, one is AMD or one is Intel, but also in terms of feature set, they're vastly different. Misfit is asking, where's the best place to give feedback, requests, suggestions for future motherboard features? Is there a specific forum for that kind of discussion that MSI pays the most attention to? Of course, you can always comment on our MSI forums. You can also comment here in the chat and give your suggestion, and yeah, we will try to discuss it internally and see what we can do. If you have something that you're specifically missing, if we're making certain design choices that don't fit your use case, please explain why you think another solution would be better, and then of course we will discuss it. So let's continue with another feature that is specifically important for me, because I always tend to lose these kind of shields, the I/O shields. So those are the little shields you put inside your case, and then you put your motherboard in there so you don't have a hole on the back of your case. And I've lost many I/O shields in the past. Now with integrated I/O shield, you cannot lose it anymore. It's also very convenient when building your system. You cannot forget to place it inside your case. But it also helps for electrostatic discharge. So to protect your motherboard essentially from shocks, from damaging from shocks, an integrated I/O shield is better for ESD protection than a regular I/O shield.
And you can never get like the metal clips stuck in your LAN port or USB port because it just bends when you put in the motherboard.
Yeah, exactly.
That happens all the time.
Bowen is asking, what's the difference between B and H series chipsets? It's mostly based on the feature set. The B series chipset offers you more features, for example, with USB ports and stuff like that. So because of the increased feature set in terms of, for example, USB ports, auto connectivity, you will usually see B460 on a little bit higher end motherboards compared to H410. And of course, B460 is, because of the additional features, also slightly more expensive than H410. Ruud, can you maybe show one of the motherboards up close?
Which
so
one
we
you
can
want?
show whichever one with the pre-installed I/O shield.
Yeah, this one also has Wi-Fi, so this is the B460M mortar Wi-Fi.
Yeah. So
someone's asking, or maybe it's looking on camera that it's a white, like white heat sinks, but actually
it's silver,
it's more
basically.
kind of silver.
Yeah.
So just to clear that up.
So right in front of it is the regular B460M mortar, the MSI B460M mortar.
That's
two of them actually.
Yeah, I'm not sure.
We have a little bit of reflection, but they come with black heat sinks, and the Wi-Fi version comes with silver heat sinks.
Yeah, so this is the silver one, and on the bottom it's the black one without the Wi-Fi.
And these motherboards are identical apart from the fact that one's got silver heatsinks and Wi-Fi, and the other one is black heatsinks and no Wi-Fi. Other than that, they're 100% the same.
Also, the Tomahawk has also a full I/O shield pre-installed.
Yeah, and also the Bazooka also comes with this. Unfortunately, we don't have that model here
that
today. But we do have some Pro Series motherboards, but they don't have them.
No, I can show you one of the Pros, and then it just have like a...
So they come with a separate shield included in the box that you will have to install in your case first.
Maybe like that. It's reflecting a little bit.
Yeah, it's a little bit difficult with the light.
Yeah. Just to give you
Chat,
an
they're
idea.
saying, seems that we have many bad experiences with I/O shields. Do you?
No, it's not from I/O shield. It's from a gardening tool. I shouldn't do gardening. My hands were not built for manual labor, I guess.
I haven't really hurt myself on an I/O shield, but I did on CPU coolers. Like in the past, you had those copper CPU coolers.
Yeah,
and they had those
really sharp.
Yeah, those fins, they were like nice. I cut my fingers on those so many times, and also on motherboards. Like back in the day when they had like loopings and stuff like that.
Also on the back of the motherboard, usually you have like the small pins through the PCB of the DIMM slot has two metal spikes, and if you just grab the motherboard, accidentally on that part, then it will also cut in your hand. Yeah,
exactly. So always be careful.
Yeah,
but
exactly.
It became a little bit better over the years. Nowadays, motherboards are not as sharp anymore as they used to be 10 years ago.
No. Also, the old PC cases, the sides of the cases were always very sharp. And
so we already talked a little bit about ESD protection, and you already talked a bit about the soldering points on the back of the motherboard.
Oh yeah.
But these motherboards, the ones with the armored design that you can find on the gaming series, they have very strong soldering points on the back, and this is because graphics cards, they're getting bigger and heavier, of course, because of a bigger cooling solution. And also, if you want to travel with your PC, it is important that you have a very strong PCI Express slot. So if you're, for example, driving your car taking your PC with you, and you drive over with at a high speed over a certain bump or something, you don't want your PCI Express to break off because of the weight of your graphics card. So that's why we have steel armor on some of our motherboards. So let's show it up close. So that's metal reinforcement on the primary PCI Express slot.
So it's a little metal.
So it will make the PCI Express slot a lot sturdier, and on the back of the motherboard you will also see the improved soldering points to really make sure that it is sturdy also when you're transporting your computer. Of course, always be careful when transporting your computer, but this will make sure that it will not break as easily with a heavy graphics card as you would with a regular solution. See a question in chat, what is the new MSI motherboard? All the motherboards that we're showing today are new. They're the H410 and B460 series. So the one Ruud was now showing is, for example, the MAG B460M mortar. And here we have the MAG B460M Tomahawk.
Yeah, the full ATX one.
Misfit is saying, I remember the old days when you'd have to use a screwdriver to install or remove a CPU cooler. I bet many people poked themselves or their motherboards during those days. Yeah, I think many aftermarket coolers you still require you to use a screwdriver to install them. So still be careful not to poke your motherboard too much. And of course your hands, but nowadays the CPU coolers are not as sharp anymore. At least most of them are not.
There's also a question about, does the B460M mortar come with a LED toggle switch? But it doesn't, only the Tomahawk.
Yeah,
so far.
There's also no RGB included on the mortar motherboard by default. So you can connect RGB components to it using the headers on the motherboard, but there is no Mistglide RGB on the mortar itself. There is on the Tomahawk, and there you will have a switch that we'll talk about later. So another important thing, of course, with motherboards is memory. In the past, we used to be quite bad as a brand on memory. So back in the DDR2, DDR3 days, we had a lot of compatibility issues with certain memory modules, and we improved a hell of a lot on this on DDR4. So on DDR4, we have a huge QLV list, so that's a qualified vendor list. And it basically is a huge list of modules that were tested with our motherboards and that are compatible with our motherboards. And to create this list, we're co-working with a lot of different memory vendors. Here in this slide, you only see a few examples because in real life, we're working together with way more than just these companies to create an extensive list of supported memory modules. And of course, the more modules are supported, the less chance you will have of having any compatibility issues with memory on the motherboard. Of course, on H410 and B460, you cannot overclock your memory. So usually it will not be as much of a hassle like Z490. With Z490 also comes with a huge QVL for supported memory modules, also with a lot of overclocking modules. So you can go way higher than Intel specification, basically. That is up to 2933 on the Core i9 and Core i7, but with memory overclocking on Z490 you can go way higher than that, if your memory modules of course can do it. The gaming motherboards also come with MSI Dragon Center support, and it's very nice all-in-one solution. In the past we had different utilities for basically everything you wanted to do with your motherboard. So you had a separate Mistglide program, you had a separate LAN manager program. Now everything is included in Dragon Center. So there you can control your Mistglide. You can get, for example, system information like temperatures, fan speeds, etc., etc. Also, you can control other components here. So if you're using multiple MSI components, so like for example if you own an MSI mouse and an MSI motherboard, you can control both of them in the same piece of software. These motherboards also come with MSI Click BIOS 5. So this is our graphical type of BIOS where you can of course do all the hardcore settings, but also easily in a graphical way can set, for example, fan curves to make your system more silent, stuff like that. Our Tomahawk motherboard, the MSI B460 Tomahawk, also comes with the very new and fast USB 3.2 Gen 2 x 2. The USB names can be very confusing, but essentially 3.2 Gen 2 x 2 means super speed USB 20G. So that's 20 gigabit per second maximum speed. And more of the compatible devices are popping up. So extremely fast external SSD storage, for example, can really benefit from the speeds that this new type of USB can achieve. So Ruud, maybe you can show it on the back of the Tomahawk.
Yep.
So it is important to note here that if you want to achieve those speeds, you need to use the Type-C connector on the back of the motherboard.
Can I get it closer? Is that?
Yeah, so that's the port that will offer you up to 20 gigabit per second speeds.
Yep.
And another feature that comes on this motherboard, for example, is the front Type-C connector. Because more and more computer cases nowadays offer front Type-C. And of course, if you have it on your case, you also want to have it on your motherboard so you can actually use it. And this actually comes on all the MSI B460 series apart from the Bazooka. So this, you cannot find this on the Pro series and the Bazooka, but you can find it, for example, on the Tomahawk, on the Mortar, but also on the ITX model that we tease you later on in this stream. Also, the multiple of our B460 models come with 2.5 gigabit LAN from Realtek. And 2.5 gigabit LAN will, of course, give you much higher data transfer speeds than 1 gigabit LAN. And 1 gigabit LAN is basically at its maximum, pretty much, because internet speeds are already achieving 1 gigabit per second in many regions. So it is expected that in the near future you can go beyond 1 gigabit per second. But if you want to connect your PC wired, then of course you also want to have a port that can do this. So we're already seeing that more and more router and switch vendors are also including 2.5 gigabit LAN support on their devices. And our MSI B460M Mortar Wi-Fi. So let's show that one up close. That one also comes with Wi-Fi 6 technology.
Which one you want?
The Mortar Wi-Fi.
Mortar Wi-Fi. Okay, sorry.
Yeah, so on the back you can see the antenna points for Wi-Fi 6. Of course, it comes with an antenna included in the box. And compared to Wi-Fi 5, Wi-Fi 6 will give you higher transfer speeds. So it goes, it's approximately 3 times as fast as Wi-Fi 5. But it also gives you a lower latency. So especially if you want to do gaming, it will make quite a big difference if you're using Wi-Fi 5 or Wi-Fi 6 in terms of latency. Many people still hate Wi-Fi for gaming. Personally, I also use a wired connection, but if you don't have the possibility, then Wi-Fi 6 can really give you a similar experience to cable connection when comparing it to previous Wi-Fi generations. I see some people talking about the PS2 connector, and also some people that are still using PS2 keyboards. At home I have an old IBM Model M keyboard. So that was like the very old heavy duty mechanical keyboards. And I also need to connect it with the PS2 connector actually. But also some people prefer to use PS2 rather than USB because PS2 actively sends the signal to the computer when input is detected, whereas USB basically asks the connected device, like the keyboard in this situation, depending on the polling rate, up to 1000 times per second. So if you will really notice this in practice, some people still prefer to use PS2 because of this, but of course you can also use USB if you prefer to.
A question about USB Type-C 4-port hub plugged into a 2x2 or 20 gig port. Will all those hub ports have the same speed? Will this have 20 gig of speed?
This depends on the USB hub you buy. If the USB hub supports it, then you can of course achieve higher speeds. For example, if you plug in a USB hub that can only do, for example, USB 3.2 Gen 1, so that's super speed USB 5 gigabit per second, then of course it will not be any faster if you connect it to the 20 gigabit per second connector. So make sure that you use a compatible USB hub to be able to achieve those speeds.
Yeah.
People are calling me a boomer because I still have a PS2 port or PS2 keyboard. Look it up, the IBM Model M. It's a really nice, heavy-duty, old-school keyboard. Worth it. Maybe it's a little bit boomer-like, but it's a nice keyboard, and I'm happy that I can still connect it and use it. Our motherboards also come with audio boost technology. And for example, the Mortar, the Tomahawk, and in the future also the ITX model, they all come with the Realtek ALC 1200 audio processor. And if we look at one of these motherboards more up close, you can see that they have an isolated PCB for the audio. So there's a small line on the motherboard, and that isolates the audio PCB from the rest of the PCB of the motherboard. And this is to minimize interference. So there are many electrical components, of course, on the motherboard. And if they're located close to the audio part of the motherboard and there's no isolation, you can get interference on there. That's why we isolated that part of the PCB. You will also see the higher end audio capacitors on there. So on the very bottom of the motherboard, to really give you the best sound quality out of this audio codec. Also on the I/O of the motherboard, you will see that, for example, this model comes with an SPDIF connector. So you can connect, if you, for example, have a speaker set that supports digital 5.1 audio, you can easily connect it directly to your motherboard instead of having to connect it using 3 analog connectors to get 5.1. We already touched on this a little bit,
right.
And that's Mystic Light. Unfortunately, we cannot demonstrate it right now, but we can show you where the Mystic Light is located. Underneath the chipset cooler, there are some LEDs, and there is a small switch on the very bottom of the motherboard that we're just pointing to now, and that's the easy LED control switch. So if you're not into RGB lighting, you can easily switch it off using that switch. Of course, you can also do this in the BIOS or in the Dragon Center software.
Yep.
But many people requested to be able to switch this off on a hardware level without having to go into the BIOS or to install any software. So in this motherboard, you can easily switch off the easy LED control switch if you don't like RGB lighting. If you do like it, of course, simply keep it on. Let me quickly check the chat.
I was just checking if I can see any lights.
Bowen is saying
if
you overclock with LN2 and the USB freezes up, PS2 is the only thing that works then. Overclockers indeed also tend to use PS2 keyboards because of that specific reason indeed. So there are different use cases where PS2 can still be useful. Of course, most people will use USB, but in certain situations, people still like to have PS2. So if we have the space, why not put it on there? Then let's talk about all the models. So these are the models that will be launching directly. So we have 4 different gaming models in our MSI Arsenal gaming segment. Of course, this is the B460 chipset on if you want to go higher end like MPG and MEG segment, so performance gaming and enthusiast segment. There you will find most motherboards with a Z490 chipset. Here there is no motherboard listed yet in the MPG segment, but I can already tease that our ITX model that's coming up will be an MPG model. And on the Pro series, we also have several B460 and H410 motherboards. Then when looking at some models individually, we already saw the MAG B460 Tomahawk a couple of times. This comes with the extended heatsink, so let's show it up close as well. Yep. It comes with a very beefy power design underneath the heatsink. Later on we will also take the heatsink off so you can show what's underneath. Comes with the front Type-C connector, 2 M.2 slots. The primary one equipped with M.2 Shield Frozzer. Comes with Mystic Light support. Very extensive I/O, so many USB ports, audio connectors, comes with a USB 20 gigabit per second. It comes with 2 LAN ports, so not only the Realtek 2.5 gigabit LAN, but also an Intel 1 gigabit LAN connector. And it also comes with both DisplayPort and HDMI outputs. Then we have our MAG B460M mortar and mortar Wi-Fi. So right now in front of it we have the 2 regular mortar models. The mortar Wi-Fi, you can recognize it of course by the antenna points on the I/O, but also because of the silver heatsink, whereas the regular mortar has black heatsinks. And this also comes with a very beefy power design, extended heatsink cooling, so it can also run the fastest CPUs in the 10th gen Intel Core lineup. It also comes with front USB Type-C, it has a 6-layer PCB, and it offers 2.5 gigabit LAN from Realtek as well.
Someone on Twitch is asking, where do you read the chat? But it's Twitch and
we can read all chats simultaneously.
Yeah.
We have a very nice program called Restream, and we can see YouTube, Twitch, Periscope, Mixer. The only ones that are difficult to see is Facebook, because there are many different pages in different regions. But apart from Facebook, we can basically read pretty much every chat. Ruud,
Yes.
do you know what time it is?
Time to unscrew the heatsinks?
No.
No.
Time
Then
for a winner.
For a winner. Ah.
So if you haven't participated yet, go to msi.com/2/insider. There you can perform certain actions. And the more actions you perform, the bigger chance you will have to win. But now it's time for our first winner. If you cannot see the link on the page, the bot will once every 6. Oh, there was a motherboard in my face.
Yeah, I'm gonna undo. Oh, sorry.
No worries.
I'm gonna undo the heatsinks anyway.
Yeah, once every 6 minutes, the bot will also spam a direct link to the Gleam giveaway in the chat.
Yeah.
And our first winner of $20 Steam wallet code for today is Luiso. I'm not sure if I pronounced it correctly, but congratulations. You won our first Steam wallet code of today. So if you haven't participated yet, go to msi.com/2/insider and have a chance to win on there. Ultron's asking, anyone won the giveaway as yet? Yes, someone just did. And if you want to win, sign up now, so you have a chance in the next drawings. If you have already signed up, no need to do it again, because you will be automatically included in the next drawings as well. So for today, you only have to sign up once, and you will be included in all drawings. Unfortunately, we don't have this model here today, but you will find it on the market soon, the MAG B460M mortar. This is also a micro ATX motherboard, or the bazooka, sorry. This is the regular mortar. Let's get this, because these are the same apart from the Wi-Fi. So as you can see, black design, no Wi-Fi is the mortar. Silver design with Wi-Fi is the mortar Wi-Fi. Then we have the bazooka. And this one is micro ATX, like the both mortar models, but it is a more entry-level design. So it still has a strong VRM design, but not as strong as the mortar and the Tomahawk. And later on, we will show you into detail like how you can see that on the PCB as well, that it will make a difference. So here you can, it's perfectly suitable, for example, for an i5 CPU. But if you want to go very, very high end towards i7, i9 territory, you will be able to get more performance out of it with a mortar or a Tomahawk motherboard. But it also comes with, for example, extended heatsink design. It comes with steel armor on the PCI Express slot. It also comes with M.2 Shield Frother SSD cooling, audio boost technology. So still a very nice featured motherboard, and really depends on what kind of CPU you want to combine it with, which one is more suitable for your type of usage. And then I'd like to give you a sneak peek of our new ITX model. This is still an upcoming model, so you will not be able to purchase this directly. But in the near future, you will be able to get the MPG B460i Gaming Edge Wi-Fi. So this is a motherboard in the performance gaming segment, so it's a little bit higher up the stack in that sense. And it's also a really feature-rich ITX motherboard. So it's mini ITX, so very suitable for small form factor builds, but does still come with 2 turbo M.2 slots. It also comes with M.2 Shield Frozr to cool your SSD, both Realtek 2.5 gigabit LAN and Intel Wi-Fi 6 connectivity, Realtek ALC 1200 audio codec with SPDIF output, and that's quite rare on ITX to find an SPDIF output, but it is included on this motherboard, and it also comes with the front Type-C connector. And I see a question in chat, will there be white themed boards? No, there are no plans currently to make white themed boards. This has to do a little bit with the signal quality also on the PCB. Usually black PCB motherboards tend to have a clearer signal quality than white PCB, at least at this point. Maybe other color PCBs will improve over time in signal quality, and then of course we will see if we can maybe also launch a white model. So no H470, no, at this point we only offer Z490, B460 and H410 motherboards for LGA 1200 CPUs. What's the giveaway? There are $20 Team wallet codes, so go to msi.com/2/insider to participate. So I already saw a few questions about the pricing. So here you see an overview of the motherboards that will launch directly. So this doesn't include any ITX models yet. But here you can see that, of course, the H410 are a little bit more affordable motherboards. They cost at around $70. So you have the H410M Pro and the Dash A Pro. Then for B460, there's a lot more choice, also with several gaming models. So right now we have 4 gaming models that you can recognize by the MAG, the Arsenal Gaming prefix. And they are the B460 Tomahawk, the B460M, so micro ATX, Mortar Wi-Fi. Then we have the regular Mortar, also micro ATX but without Wi-Fi. And then we have the more entry-level B460M Bazooka motherboard. And in the Pro segment, we have the B460M Pro VDH Wi-Fi, the B460M Pro, and the B460M Dash A Pro. So maybe we can show some of these Pro models also up close.
Yep.
So let's maybe start off with the B460M Pro VDH Wi-Fi.
Yeah, that's this one.
So this is not specifically targeted at gaming, but it still offers quite a broad feature set. Also, if you look at the I/O, for example, you can see that this also comes with Wi-Fi support. It also has a steel armor reinforced graphics card slot, VRM heat sinks to make sure it can also power somewhat beefier 10th gen Intel Core CPUs. Some people are asking about the prices comparing US dollar to euro. And here it's important to mention that the US dollar prices are excluding VAT and the euro prices are including 20% VAT. So these are the recommended prices that MSI recommends to the reseller, but resellers can define their own prices. So this is just an indication, but of course based on your region, based upon availability, but also based upon the taxes in your region, prices can differ slightly. And because the USD prices are without VAT, they're generally a little bit lower than compared to the euro prices that already include VAT in this overview.
I saw another question. Someone was asking about H470.
Yeah, I answered that question.
Oh, you did?
But
okay,
right
so.
now we're not offering any H470 motherboards.
No.
From our perspective, we think that B460 offers all the features for the segment that H470 covers.
Yeah, it's too close to Z490.
Yeah, and C490 of course offers overclocking capabilities where H470 doesn't.
Yeah.
Any news about the release date of the MAG Core Liquid? I don't know an exact date, but it should be out in a couple of weeks. So make sure to check with your local retailer. He might be able to give you some more information about when it will be available in your specific region. People are asking, is there no 550? Yes, there are B550 motherboards. We actually did a dedicated live stream about B550, which is of course AMD AM4. So make sure to check it out. You will be able to find it on YouTube. If you search for MSI Insider B550, I'm sure you will find it. This is for, yeah, these are indeed for Intel CPUs. I see a question in chat, why are B550 motherboards more expensive than B550 or B450?
450, yeah.
Several reasons. With B550 you get PCI Express Gen 4. This means you need special switches that support Gen 4. You also need a special PCB that gives you an even clearer signal, which is more expensive compared to a regular type of PCB because of Gen 4, but also most B550 motherboards come with a better feature set, stronger VRM design, so many aspects that make the total price. Yeah, so we already talked a little bit about the VRM design on these motherboards, and there is a reason that some of these motherboards have a very strong VRM design, because even if you don't have a case Q CPU, you can extract more performance out of your CPU if you have a stronger motherboard, basically. So here we see an overview of the power limits that we are using on our B460 and H410 motherboards. On the very left, you see our ITX models, so the B460 I Gaming Edge Wi-Fi and the H410i Pro Wi-Fi. So these are not available directly, but will be available later on. And then also our MAG B460 Tomahawk and MAG B460M Mortar and Mortar Wi-Fi. They all offer both short and long duration power limits, so PL1 and PL2 power limits of 255 watts. When comparing this to, for example, the Bazooka or the Pro models, they offer PL1 limits of 132 watts and PL2 power limit of 180 watts. And that's also quite a big increase. We just, with Simon, we talked about the TDPs of these CPUs, and the TDP of even the 10-core 10900 is, for example, 65 watts. Yep. So if you stick to that limit, you will not be able to extract the maximum performance out of that CPU. By increasing these power limits to 135 long duration, 180 short duration, or even 255 on both short and long duration on the top end B460 models, you can extract more performance from these CPUs.
Yeah.
So also performance-wise, it does make sense, for example, to go for, if you're in a doubt between Bazooka and Mortar, Bazooka will already give you an increased power limit compared to standard TDP, but with Mortar, the power limit will be even higher, and it will be able to get even more performance out of those higher end CPUs. So here you see an example of the VRM design, like on our Mortar and Tomahawk motherboard. So maybe we can grab the Tomahawk with it and just show it on the motherboard itself. So as you can see, you have a lot more MOSFETs. Let me show it up close. Yeah, so maybe you can point at the PWM controller.
The PWM controller.
That's where the power basically comes in, and that will transfer the power to the MOSFETs. Yeah, it comes in from the connector to the PWM controller, that will divide it over the MOSFETs. And by having stronger and more MOSFETs, these motherboards are able to run these higher end CPUs at higher power limits for longer periods of time. Can you maybe grab one of the more entry-level H410 Pro models? Then we can see the difference between them.
Yeah, let's see if we have the... This is the H410M Pro.
Yeah, so here you see that you don't have as many MOSFETs available on the motherboard. So this is perfectly fine if you want to run a more entry-level CPU. You will still be able to get maximum performance out of this. But if you're going for a more high-end CPU, then you will benefit from a beefier VRM design.
Yeah.
This is an example of Prime 95 with AVX. So that's basically the maximum load you can put on your CPU for 30 minutes on a Core i5 10600. So as you can see, the blue line are the motherboards with a short duration power limit of 180 watts, long duration of 135 watts. With this CPU, they're perfectly able to run this CPU at maximum performance also for longer periods of time. However, if you're going for a higher end CPU, like for example the Core i7-10700, here you can see that if you get a motherboard with a beefier VRM design and higher power limits, it will sustain way higher clock speeds than more entry-level motherboards. So here you will basically get more performance out of a higher end B460 motherboard. Later on we'll also demonstrate this. We have 2 test setups with Core i9 CPUs on Mortar motherboards. And we will run it both with the Intel recommended settings, so the power limit, and we have an MSI enhanced power limit, so with the 255 watts for both PL1 and PL2. And of course with the Core i9, which is a 10-core CPU with 20 threads, this difference becomes even bigger. So on the red line you see the higher end B460 motherboards, and on the blue line you see the more entry-level ones, but still they already give you quite a lot more performance compared to the Intel recommended settings. I see a question, when will B550 arrive in the stores? Unfortunately I cannot give you an exact date for that, it's still under NDA. So we have already shown you our motherboards, we have already talked about the pricing of these motherboards, but unfortunately I cannot give you an exact date yet. Here you see an example of even a 10900K CPU, so that's the top end model in the 10th generation Intel Core CPUs. So this is the overclockable 10th core CPU on the MSI B460M Mortar motherboard, and this is running the CPU at full load in Blender, and as you can see the Mortar can easily run this CPU with very good VRM temperatures, and also run it at all cores for 4.8 GHz without any problem.
Yeah, because of the unlimited power limits.
Yeah, because indeed. Yeah. And of course because of the cooling on the motherboard itself, it can easily sustain these temperatures even when you're stressing it for a longer period of time.
Yeah.
People are asking, do you have motherboard for AMD CPU? Yes, we do. We have, for example, X570, B550. In previous live streams, we've talked about them, so make sure to look them up if you're interested in one of those. Cashew201 PS3 is asking, are they the same VRM? Which 2 models do you mean exactly there?
I think if you compare for the B460, the Mortar and the Mortar Wi-Fi and the Tomahawk, they have almost identical VRM. Yeah, design is the same. Yeah, only PCB is a little different.
Yep, exactly. And the size is of course different. One is ATX,
the heatsink might be a little different between the Tomahawk and the Mortars, but the Mortars are basically
both
the same.
come with extended heatsink VRM design and indeed the same VRM components on the PC.
Exactly. Yeah.
So we've now talked about it in theory, but I think it's time to show this. But before we do that, maybe another winner?
Why not?
So if you haven't participated yet, go to msi.com/2/insider. If you already participated, no need to do anything. You will automatically be included in all drawings. And our next winner for today is... Oh, difficult nickname. Mado Ampere, congratulations. You also won a $20 Steam wallet code. We will email it to you in the coming days. So congratulations, you also won one of the Steam wallet codes. If you haven't participated yet, go to msi.com/2/insider or directly click the Gleam link that gets spammed in the chat on at least YouTube and Twitch, it works. So yeah, let's look at the performance of the CPUs with those MSI enhanced settings compared to the Intel recommended settings.
Yep, okay. So
basically we have two systems side by side, so you can see them both in front of Ruud.
Yeah, I have 2 sets of keyboards and mice here, so I can control them both. And I will show you what we've set up in the BIOS. Basically, they're both running i9 10900Ks, but as for B460, people don't usually go for the K CPU. So
because you cannot overclock with them anyway. You cannot unlock the multiplier.
Exactly.
On them.
So what we've done in the BIOS is we simulated the clock speeds for different threads to simulate a 10900 non-K. So that will also give it, consume a little less power than a 10900K. But this board is more than capable of running the 10900K as well.
And of course, people will be curious, why are you using a 10900K then and not the 10900? Because of the very simple reason that we needed to have two identical CPUs.
Yeah.
And unfortunately, we didn't have two 10900 CPUs, so we decided to go with two 10900Ks and basically put them on 10900 settings, so to say.
Yeah, so basically the settings are here below. These are the ratio, the multipliers.
So this is the Intel Extreme Tuning Utility that we also talked about with Simon before.
Yeah, exactly. And if one core is active, then it can thermal velocity boost up to 5.2 gigahertz or a multiplier of 52. So the base clock bus clock is 100 megahertz and times 52 will be 5.2 gigahertz. If you run all cores active, then it can thermal velocity boost to 4.6 gigahertz. With these beefy coolers, we have 2-core liquid 360Rs on top of them. These should stay well below the 70 degrees centigrade mark. So a thermal velocity boost would also work on a 10900 with all cores. Of course, the difference between these two is in the power limit. So the right model is set up as the power limits are set up for Intel recommended power limit settings. So basically a short boost power of 225 watts and a long power maximum of 65 watts, which is also the TDP, and that can do that for, I see I've made a mistake here. This says 1 second. That's not correct. This should be 28 seconds. I think it's a misread from the XTU utility. But to be sure, let's set it up to 28 just to make sure. Okay.
Someone in the chat is asking, is this B460 versus B365? No, we're now having two identical setups, both running the MAG B460 and Mortar motherboard with a Core i9 10900K CPU. Of course, this is not a very common combination, but this is to show that even if you get a very high-end processor on these type of motherboards, you can still get maximum performance out of them by increasing power limits.
Yeah. So if we're looking at the right system, that's the one with the MSI enhanced power limits, and then you can see that the short boost power is 255 watts, also shown in the table in the presentation, but the long boost power is also 255 watts. So basically there's not really a limit there.
So this is basically the PL1 and PL2.
Yeah, exactly. Yeah, and now you see that the boost power time window is set to 1 second, but you can change this to anything because short and long power are both the same. So it doesn't really matter which duration you choose because they're identical. Also, you will see one other thing, and that's the processor core ICC max. Maximum current draw. This is set by our BIOS also to protect the power circuit on motherboards. And for the lower end motherboards is set lower to 180. For example, the H410 M Pro is set to 180. For this Mortar and Tomahawk, it's set to 210, which is also the maximum a 10900 can draw. So let's see what the results will be if we benchmark it. I've chosen Cinebench 20 as a benchmark. Let me close XTU for good measure, because it's always running in the background if you close it. I'm not sure.
Everyone is asking, can you auto overclock the CPU, or do you have to tweak the settings? This is not technically overclocking. It's more using the boost frequency for a longer period of time, basically, and also increasing the current that it can draw to reach those boost frequencies. And you don't have to do anything for this, by the way. This will work out of the box. So here on the left we see the system with the Intel recommended settings, and on the right you see the one with the MSI enhanced settings. And this can differ slightly per motherboard. So in this situation it's the settings for the B460M mortar motherboard.
Yeah, I'm gonna start Cinebench. Let's hope that it will run in sync. Then we can also see that one is faster than the other, or finished the job faster. Here we go, in 3, 2, 1. Hey, it worked.
That was good timing.
So what we see is that it starts in around 169, 170, but you will see in the Intel recommended, it drops to 65 quite quickly. We've set it up for 28 seconds, but it's much shorter than that. So it's like an exponentially weighted average. I don't exactly know how that's calculated, but the more load you put on the CPU, the quicker it runs out. It's like a bucket of energy, and if the energies run out, then it will fall back to power level 1, power limit 1. On the MSI enhanced one, on the right side, we see that it's running 170 through whole the Cinebench run, which is already finished, and the left one is still running, but also the clocks dropped because of the 65 watt power limit, PL1. So now that job is also done, and you can also see that the score is, this would be the normal score for Intel recommended settings, and this will be the score if you run with the MSI enhanced power limits enabled. So that's quite a big difference. I must say the performance will be even higher if you don't run OBS and NDI in the background. So then it would be the MSI enhanced power limits would run at about 6,000 points, and the other one is running about 4570.
Yeah, so this is because we're also capturing these screens, and we're using NDI for that. So that's like a tool that through OBS we can directly capture these screens. But it does have a slight impact on the performance, because it does give a little bit of CPU load.
Yeah.
So that's why the scores are now slightly lower than it would be when we would switch NDI off. But yeah, you can clearly see the difference also in clock speed. If we look at the top graph, you can see a huge dip in the Intel recommended settings, of course, because that power limit kicks in.
Yeah.
Whereas
so right here, it's behind your head.
Yeah.
But it's running about 3.2 to 3.3 gigahertz on average, and the MSI one is running about 4.6 continuously. So that's the thermal velocity boost, because the temperature got only up to like 60 in the end. So
yeah, people are saying show the thermals. Well, they're actually in the second graph. So you can see the CPU temperature, and
so,
indeed it does get higher on the enhanced settings, because the CPU is able to draw more power.
Yeah.
More power basically means more heat. So it is increasingly important with these increased power limits to have good cooling on your CPU.
Yeah.
Later on we'll also demonstrate this using different CPU coolers.
So if you're running an i9 with the Intel recommended settings, you can run Cinebench forever and then say, okay, my CPU is only running at 37 degrees centigrade. So
this is with high-end cooling.
This is with beefy cooling. So yeah.
So this is with the MAG Core Liquid 360R. So that's a 360 millimeter radiator. This is high-end all-in-one water cooling. Of course, if you're doing this on a way smaller air cooler, you will not get these kind of thermal results.
Yeah. So this is the Cinebench one, and of course, when the power limits kick in, the power limit 1 is kicking in. You can see it in the graph here, but sometimes Michiel is in front of it. And also on the bottom, there's like another one. Let me show you. Yeah, that will work, but I will start a Prime 95. There's something wrong with this one. Not sure what happened to the icons. My desktop is being...
question, I'm in the contest, but when I press the Twitch link there, it did not go with Twitch. Should work. You should be able to use the Twitch link there as well. Please let me know if anyone else has got similar problems, because then maybe we need to dive into that.
Okay, what you can see now is that I'm starting Prime 95, which is using AVX on a heavy basis. It starts out at 200 watts, and the Intel recommended one. So it can do this only for a very short period of time, because then also the energy bucket will run out, as they explain it in Intel's way. And then it falls back to 65 watts or thereabouts, and you can see that the clock speeds will run between 2.7 and 2.8 gigahertz continuously. It will be nice and cool, of course, with this kind of heavy cooling. Also, you can see here, well, it's actually blocked a little bit, but here it was running into the ICC Max. I can maybe bring that up a little bit. For example, here. So here it is limited by the ICC Max, and then later on it will be limited by the PL1 on the Intel one. If we're looking at the MSI enhanced power limits, you will see that the PL1 is not tripped because it's the same as PL2, and at 255 watts, and you can see that it's running into the ICC Max. That's also the reason why it's capping the CPU frequency to 4.4 and not 4.6 thermal velocity boost, because the temperature is still just under the 70 degrees. You would expect to have a 4.6 all-core clock speed, but since it's running into the ICC Max limit, it can only do 4.4 gigahertz. But this is only with the AVX heavy power drawing programs.
Still, if you compare it, for example, to the recommended settings, this is already a way higher frequency, right?
Yeah, that's way higher, and this can run indefinitely, or as long as your cooling is equipped to do that properly. Yeah, Prime is a very unique program together with some other stress tests like OCCT or AIDA's FPU test, stress test, and also LinPack or other stress tools that are based on LinPack. They exhibit the same kind of power draw. But if you're looking at real-world programs, then none of the programs is drawing anywhere near that kind of power draw on an Intel CPU. Also, if you run the same test on an AMD, then the power draw between AVX and non-AVX isn't that big. So it's really an Intel thing and a Prime 95 thing, or the stress tools. So this is basically what the performance difference will be if your cooling is capable of handling those enhanced power limits.
But you're using a very over-the-top cooling for especially like a mid-range system. Usually cooling will not be as extreme as a 360mm radiator.
Correct, yes. There's also because we had two of the same spec coolers.
Yeah, we needed to get two identical platforms to really be able to compare them to each other.
Yeah, but for an i9, even a non-K, it's not that out of this world to have like
True.
a 240.
Yeah, with the increased power limits, indeed.
Yeah.
So if you run, for example, a Core i9 10900 CPU on a one of the more higher end B460 motherboards, then it will benefit you to have a cooler like this. Maybe we can also demonstrate that by downgrading the cooler a little bit to see what it does with performance. So maybe we can do another run with this cooler and then compare the scores to running the same system with a more simplistic air cooler.
I will shut it down, this one, the MSI one.
Do you still remember the score?
Yeah, some
5800 something?
58 something. I've also written it down because
okay, good.
5810 was the run before this live stream.
This is a very wrong image, Ruud.
Oh, sorry. I'm missing some bracket.
We need to have age restrictions if you
oh, here it is.
do like that.
Sorry. Well, sorry if anyone got offended. So. Okay, let's undo the water cooling.
So another question, when will B550 motherboards be available for purchase? Unfortunately, I cannot tell you yet. I can only say soon. So now we're going to replace the MAG Core Liquid 360R with the Core Frozr S. So we're going to change like the very large all-in-one water cooling for a, well...
Yeah, it's still...
it's a properly sized air cooler.
Yeah, I would say it's a nice mid-range air cooler. And a lot of them, a lot of brands have coolers like this, and they perform also very similar.
Yeah, so it's a cooler with 120 millimeter fan on there.
Yeah.
Got some copper heat pipes. So this will already be quite a big upgrade when comparing this, for example, to a stock cooler.
Yeah.
That comes included with your CPU. So yeah, let's go for the mid-range cooling solution. So we just saw the performance with the high-end cooling solution. Now we're going to test it with a mid-range cooling solution, and then we also have a box cooler laying around somewhere there.
Yeah, it's not the latest one, so yeah, we cannot show.
People in chat are saying, Mike keeping coolers in his pants confirmed. Yeah, Ruud was searching for them. Mr. Masterdog saying advertise TDP 65 watts, true TDP to actually get the most out of your CPU, 210 to 250 watts. You need beefy cooling. Yeah, it depends very much on which CPU. With the i9s, the 10 cores, you can definitely get way more performance out of it by increasing power limits. This is of course different when you're running an entry-level CPU. So if you're, for example, running like a Core i3 or maybe even a Pentium or something, then you will not go beyond that TDP. You will not gain any performance by having higher power limits.
I think there's also a bit of a confusion between, about what TDP means on the Intel platform.
Yes.
On the AMD I also don't understand, but the Intel is not that far-fetched, I would say. Intel says if your CPU is running at 100 degrees, which is the maximum it can run on, and to maintain the base frequency for a 10900K, I believe it's 3.7 gigahertz, it will need a cooling that can absorb a minimum cooling that can absorb 125 watts. So to maintain 3.7 base frequency, that's basically what Intel defines as their TDP. So don't expect any boost anymore, because then you need a cooling that's a lot better. That's also exactly why increasing the power limits is not considered overclocking. It's just
basically it's like sustaining the boost frequency of your CPU.
Yeah, but you need two things. That's one is a motherboard with a VRM that's capable enough, and the other thing is a cooling solution that is capable enough. So basically, that it will not thermally throttle.
Yeah.
So normally, if the power limits are at Intel spec or Intel recommended settings, I should say, then it's power limit throttling, and if you run unlimited and your cooling is not enough, then it will be thermal throttling.
Yeah, so all MSI H410 and B460 motherboards come with these increased power limits.
Yep.
So depending on the model, it is either 135 long duration, 180 watts short duration, or with the higher end models, like for example the mortars that we're using now, but also the Tomahawk, and in the future the ITX models, they will have both PL1 and PL2, so short duration and long duration power limit of 255 watts. Hussein is saying also this is open system in a cool room, so numbers will vary.
Exactly.
Yeah, this is indeed in an open test setup.
Yeah.
It's like normal temperature here, not very warm nor very cool.
And for the water cooler, it doesn't make a world of difference, but for the air coolers, or especially for the box cooler, it does make a difference. Because
and it also depends very much on what type of case you have. If you have, for example, a case that is a lot of glass and does not have as much airflow as, for example, when you have a mesh front, then you will probably have higher temperatures, so you will need perhaps beefier CPU cooling to compensate for that.
Reapplying some thermal paste again. Same paste as before.
Can you turn the camera a little bit?
I can, yes. So
now replacing the CPU cooler from the all-in-one liquid cooling with the 360mm radiator.
The cable is a little bit tied up, so okay.
To a moderately sized air cooler, tower cooler.
Yeah. Also, we give some specifications about the air cooler. In our specs, we say this cooler is capable of running 150 watt TDP. So actually, it could do a little bit more. At least in this kind of
And when comparing that, for example, to the Intel stock cooler, the ones from the previous generation, they were 65 watt TDP coolers, and now with the new 10th gen Intel Core CPUs, Intel is boxing their CPUs with 80 watt TDP CPU coolers. So this is already, even compared to new box cooler, this is still quite a big step up. And of course, with the 360mm all-in-one water cooling, you will go far beyond this. So you will gain even more.
Yeah. We don't have a new Comet Lake boxed cooler here.
No, unfortunately.
But we found a very old one, an Ivy Bridge one. For example, for the i5 3570 and so on. And those were actually 77 watt TDP CPU. So that's quite close to the one Intel should be shipping now with the Comet Lake.
Yeah, and like Simon also explained, the cooling mount from the previous generation compared to the current generation, even though they're different sockets, they have the same cooling mount. So you can still use your cooler from the previous generation on your new 400 series motherboard. But CPUs are not compatible with previous generations.
There we go.
In chat they're saying, please show how much thermal paste Ruud is applying and in what pattern, so we can all complain and rage.
I made like a small square. Yeah, if you have the CPU like this, then I just usually do like a small square. And since we're using like this kind of containers, then you can just spread it out a little bit. Usually the pressure of the mount is just applying.
I usually on CPUs like this, I just put a little bit in the middle and I let the CPU cooler do the work, the pressure.
Yeah, me too.
But that's for a CPU this size, because if you're using a larger CPU, like high-end desktop platform, for example, if you're using a X299 motherboard or a Threadripper on a TRX40 motherboard, those CPUs are much bigger. So then it does make sense to already apply the thermal paste onto multiple areas of the CPU, or already spreading it over your CPU to make sure that you get proper contact all over the CPU.
Okay. So
people are already complaining about that you did a square. Crosses are better, they're saying.
Yeah.
It's all a matter of preference. It will all work.
For small CPUs, I don't think the pattern matters a lot, and
you can put a smiley on there if you want.
Yeah. And also the amount is not really a big thing, but the more you put on, the more messy it will get if you replace the cooler. So we're back in the BIOS. Maybe you can switch to the main screen, and it's working. Yeah, that's great. Okay, so let me show you where the power limits are. So here we have all the turbo. The adjusted turbos we had to simulate the 10900 with a 10900K CPU. If you go to the overclocking part to advanced CPU configuration, here you will see the long duration power limit, and that's PL1, and also the long duration maintained in seconds, and default is 28 seconds. It says here, but in XTU it will show you 1 second. So I think that's like a BIOS software misread. The same happened on the Intel one, Intel recommended one. And the short duration power, that's usually the boost one, and this is the power limit 2. Also the CPU current limit you can adjust, but I advise you not to do so, because this is chosen for this particular motherboard and this particular VRM. So
this is also to protect the motherboard, that you're not overloading it.
Exactly. So if you want to play with this one, it's at your own risk, and make sure the VRM is properly cooled. I think this cooler with an open setup is capable of running this unlimited. Because we saw with the water cooling, it's running about like 170 watts, and this cooler is rated for 150. So in a well ventilated case or in an open setup like this, this should be doable. But for people who want to try the power limits and also want to see if their cooling is capable enough, make sure the CPU fan is running at max speeds. So just in case, that will show the maximum cooling capability of your cooler. So if this runs fine, then you can start lowering the fan speeds at lower.
Just fiddle around with it a little bit.
Yeah, then you can set up the fan profile in this one with a smart profile. Usually I will just go to, once the CPU reaches 80, then you can set it up so it will go to 100% fan speed. Then you can fiddle around with the lower frequency range, and that's up to you. So it depends on how much noise you want to tolerate, what kind of CPU temperatures. But
people are asking about XMP on B460.
XMP is possible, but it's limited to a maximum of 2933 on the i9 and i7. If you go i5 and below, it's 2666 maximum. So that's the same for B460, H410, and if there would be H470, it would also have the same limit.
But by using XMP, you can, for example, get lower timings and stuff like that. So you can use it, but not if, for example, if you have like a 3200 or 3600 megahertz kit, it will run at a maximum of 2933 megahertz on a B460 motherboard.
So basically I only adjusted the fan speeds, and these fan speeds were just set up so it would run 1500 RPM on the Core Liquid 360. So I thought that was a nice fixed fan speed for this cooling with this kind of load. So I had to choose something. So it was the same on the Intel recommended setup. So basically we can do the same again. I can show you XTU, but I can just go directly to HW info and also to Cinebench. Now I don't have to time it anymore, so yeah.
So the previous one we had 58 something, right?
5810.
5810,
Yeah. The CPU temperature, I'm not sure what it was. You have to look back at it. I think it was about 60.
Yeah, I believe so, around 60 degrees.
So this will be a little bit higher. So the package power will go up to 170-ish watts. That's very similar. Also, the CPU package is a little bit higher, so it's already at 71. So it will increase, but since we're in an open setup, test setup, this would be capable. And don't worry if your CPU package runs into the 80s. 80s, even high 80s is not a big problem. Most notebooks are set up to run into their thermal limits before they run into their power limits. So it's not very unusual for Intel CPUs to run. And Intel CPUs are very robust, so they're not easy to destroy.
But here you do get, at a certain point, you get over 70 degrees. So thermal velocity boost will not work over 70 degrees.
So we're running a little bit too high now, because this would drop at around this point. It would drop to 4.5 on an original 10900. So power would also decrease a little bit. So instead of 170, it will probably run 165 or something, because the 100 megahertz is not a huge deal. That's like 2%. So okay. So the score is also a little bit lower, and
but still pretty good.
But still very good. It's a lot better than Intel recommended power limits. And if your CPU is running into thermal limits, then just make sure that you will adjust power limits and go step by step. Don't go the whole. Don't take the whole power away. But if you say, okay, 170 is too much for my cooling setup, then lower it to 150, for example, and test again. And then you can get the maximum performance out of your CPU, motherboard, and cooling system.
So for this specific combination, if you're going, for example, for a B460M mortar with a high-end CPU and a proper air cooler, so I would say moderately sized air cooler with 120 millimeter fan, you can already get quite a lot more performance compared to the Intel recommended settings.
There's one load, of course, the Prime 95, I showed it before, that will still do 200 watts. So this cooler will not be sufficient, and you will run into thermal limits even in an open setup. It will take a little bit, but it will run 205 watts. So this is if you let it run long enough, then it will show you that it will go into the 90s, the CPU package power, the CPU package temperature, and the 205 watts is too much for this cooling. So if you want to do that, you need to have like a water cooling setup, especially if you're building this inside a case. So the unlimited power limits we've set up in the BIOS at the moment are not ideal for this kind of cooling setup. So a better way would be go to a long duration power limit of 170 and a short duration power limit of, for example, 190. That would be a good setup for this particular cooling setup at this moment, so open test bench.
So this is still quite a beefy air cooling, but of course when you buy a CPU, it comes with a smaller CPU cooler out of the box. So maybe let's take a look.
Let's try that one. Yeah.
How it performs with the stock cooler.
Yeah.
And in the meanwhile, because I saw some people asking, did they already do a giveaway? We did a few, but we will do some more. So if you haven't participated yet, go to msi.com/2/insider. There you can perform several actions. The more you perform, the bigger chance you'll have to win. Every 6 minutes, the bot will also spam the link in the chat in at least YouTube and Twitch. And now let's see who our next winner for today is. Well, Ruud replaces the bigger air cooler for an Intel stock cooler.
Yeah. Maybe it's nice to see the difference in size of the cooler.
The computer is thinking about our next winner right now. It will be there shortly.
I don't know if you can switch to the detailed cam.
Oh, let me. There we go.
Yeah, these are the size differences of the air cooler. And, you know, it should add a fan as well. But the boxed one is with a copper insert. So this is the one from the Ivy bridge, so the 3570. And for example, the Coffee Lakes, the Coffee Lake Refresh, like the 8 and 9 gen Intels, they had to do without the copper insert, so they were really limited to 65 watts. This one should go up to 77.
Let's go to our next winner for the giveaway, who won a $20 Steam wallet code. Congratulations, Fernando. You will receive the code in the coming days in your email. Congratulations, you also won a $20 Steam wallet code. So if you still want to win today, last chance to sign up, go to msi.com/2/insider. Hussein is saying second. This is the third winner, Hussein. So before Fernando, we had Mado Ampere and Luiso, who already won a $20 Steam wallet code. Gianandre is saying, always watch MSI stream. You'll learn a lot from that. Thanks, MSI. Thank you for watching as well. I'm glad you like it and you learn from it.
I'll check that later.
You lost a screw?
Yeah, no, not a screw. It's a white plastic rivet or something. I just fell off the metal screws of the core frozzer.
Okay.
You know, the back plate is from the cooling is going through the motherboard, and if you
Oh, we'll find out later.
Yeah, we'll find that tomorrow.
So please note that this is not the box cooler that comes with the 10th Gen core processor.
No.
So unfortunately, we didn't have that one. So with the updated cooler, you should be getting a little bit better thermal performance than with this one, because it's an 80 watt TDP cooler, whereas this is a 65 watt TDP cooler. But this is to demonstrate you what kind of difference it makes when you have a better cooling, when having these increased power limits on the motherboard.
Okay. Also, the fan on this always takes a little while to start.
To spin up.
Yeah. Oh, I was too late. But
Now you're already in
don't worry,
Windows.
I have a batch file that can just propel you back into BIOS quickly. So we know this cooler should be rated for about 80 watts. So I would suggest also to keep those.
Some people in chat are worried about PCB bending when you pushed in the cooler. It should be okay. They can handle something.
Actually, that's by design. Intel wants some pressure on the CPUs as well. But also the PCBs are designed to withstand those stresses, the pressure. So if you can switch to the bias one. So I was already going for from the main bias. Actually, there's two sides to this bias. There's a easy bias, this mode, and if you want to do overclocking, you go to advanced mode, and then go to overclocking, and there we go, and then the CPU configuration. So if we would run this kind of cooling with the unlimited ones, then it will overheat quickly and you will run into thermal throttling quite fast. So I don't recommend doing that. For long duration power, I think 80 watts should be okay. That's already, it's 15 watts over the Intel recommended one. And okay, let's keep this one at 28 seconds. And short duration power, what should we set? 125? Why not? So one thing I forgot is also this one, go to the, I was setting up the smart fan mode with the core frother. But if you unclick the smart fan mode, then it will run your CPU fan at 100%, and that's exactly what I want. So smart fan control disabled. So short power 125 watts and long power 80 watts. Let's see if that works, or if this cooling is capable enough. And this is how you can play around with this kind of settings and get the most out of your CPU performance. So because if this setup is able to run this kind of settings, doesn't mean your setup is able to run the same. Because
even if you're using the same configuration, you're probably
exactly.
using it inside a computer case,
also
which will also make a difference.
Yeah, different cases will influence the cooling capability of your CPU cooling, and yeah, you need to fine tune it for every build you make, and that's where also Intel designed the power limits for. So it's for the system integrator, or the system builder, if you will. And if you're building it yourself, then it's up to you to set those power limits. It's you're the only one who can determine what build you're making. For last week we had the Trident X with a 10 gen, also 10900K CPU inside, and that power limit was set to a long duration of 150, and that's really well within limits. Now we can see that the 80 watts is enforced. So 80 watt power is because power limit 1 has tripped here, and before that it was running 125 watts for a short period, and then it got up to 82. Now it's nicely doing around 70-ish, so 70, 71, 72 maybe, but that's all fine. So this setup can run forever, no problem. Also, since we've lowered the long duration power and the short duration power to the capabilities of this cooling, so compared to the Intel recommended spec, we used to have 4280, something like that, and now we have 4645. So Intel recommended power limits with a beefy cooling is still lower than the Intel box cooler with increased power limits. So it's up to you to set those power limits.
But here we can already see that you go at a certain point a little bit over 90 degrees. So if you're using a cooler like this,
no, 80, yeah,
or
82.
a little over 80, yeah. So if you're using a cooler like this, if you're running this at way higher power limits, then the cooler cannot cut it anymore.
Yeah. Also, basically the short duration power time window, so now we've chosen 28 seconds, it basically just means how much heat can your heatsink buffer. So it will give you some time to buffer. I mean, it still needs to cool down that particular heat, but once the power limit is reduced from 125 to 80, then you can see also it will reduce the temperature nicely. So this is fine. Even if I would run Prime 95 and
yeah, Mr. Masterox, you're correct. This is power throttling, not thermal throttling. So the power limit will kick in, and by doing so, it will lower the temperature and also the clock speeds.
Yeah.
So you will lose some performance.
Yeah. So now it will run a little bit lower, but it will run 125 watts. It will let the CPU package temperature climb to the same degrees probably, and then it will drop just about, I would expect now, but okay, it will just take a little bit longer. And then it drops off. So even Prime 95 is covered by this power limit. So the short duration will still get it up to 82 in this configuration. Also make sure you have some now we're in an air-conditioned room with an open test setup. Also make sure if you're testing in the winter and your room might be colder, you still have some temperature room or extra. So you will, if your room gets up to 30 degrees, it still needs to cool the CPU properly. So,
Mr. Masterdock saying if you have the money for an i9, you should go for all-in-one or beefy air cooler. Yeah, I think so too. If you want to get the most out of that i9, definitely go for a higher end cooling solution.
And just sell the box cooler.
Spoofast asking what about MSI Core Liquid cooling? Previously, we actually tested both configurations with the Core Liquid 360R, so that's the version with the 360 millimeter radiator. And yes, there you can easily run it at the 255 watt PL1 and PL2 power limits for a sustained period of time without any issues.
Yeah.
Fanny Tooth Gaming is saying, what cooler would you recommend for the CPU? It really depends on how you want to use it and what kind of environment do you want to use it and what kind of case you want to use it.
Yeah.
I would say in most situations you could already do with the 240 millimeter version. So Core Liquid 240R should already be sufficient.
I think that's a nice cooler for both the i7 and the i9s.
Yeah, I think so too.
If you want to go case Q with Z490, then probably the 360 would be more for you. Yeah.
Then it's worth the investment.
Yeah.
And also if you live, for example, in a very country where it's usually very hot, then of course you will benefit more from a 360 millimeter than in countries where the temperature is lower already.
Yeah.
Yeah. So I think that was it for today, right?
Yeah, that's all.
Then let's close it off with a final winner for today. So our last winner of a $20 Steam wallet code will be interesting nickname. The winner is, who is the winner? Well, you are the winner. Congratulations, you also won a $20 Steam wallet code. You have a very good nickname. So yeah, that was it for today. If you didn't win this time, next week we will have a nice new giveaway, so make sure to be there. Still a secret topic for next week. We're trying to work something cool out, but we're not entirely sure if we can already do that next week. So I will not tell you yet what it will be, but make sure to be here again next week, same place, same time, new live stream. Ruud, thank you for joining again.
Yeah, thanks.
All the viewers, thank you for watching.
Thank you for watching.
And see you next week, and goodbye.
See you next time.